What if we aren't the first thinkers, builders, or map makers to walk this planet? Not myths of lost continents or weekend visitors from the stars, but something homegrown, biological, intelligent, in a way we might not fully recognize, rising long before pyramids and satellites and bedtime science channels, then vanishing so completely that the Earth itself forgot. It sounds like storybook material, and in a way it is, but it's also a legitimate scientific question that geologists and climate historians sometimes whisper about. Not will we find skyscrapers under ice, but something subtler. If a civilization existed millions of years ago, would we be able to tell? Would any trace survive the steady, unhurried work of weather, water, heat, and stone? The earth does not keep a diary. It edits, it buries, it remakes its pages. Wood rots, metal returns to ore, bones dissolve, languages evaporate faster than footprints in rain. What persists must be lucky, sealed, or stubborn. Before we hunt for ghosts, we need to slow down to the planet's tempo. Take a breath. Notice the quiet. Imagine time not as numbers on a screen, but as layers of dust, silt, shells, and ash, pressed and lithified into a memory that forgets almost everything. Tonight, we'll walk that memory with soft steps. No loud debates, just patient questions. If this kind of slow curiosity feels like your pace, you're in good company. Settle in. Let your thoughts match the drift of continent. We'll look backward past history, past writing, past the brief flicker of us, into deep time where the planet's habits, not our hopes, decide what lasts and what doesn't. When most of us say ancient, we mean a few thousand years. Pharaohs, Stonehenge, baked clay with neat wedge marks. Even the first farms are only about 12 millennia behind us, which is closer to now than to nearly anything else Earth has done. But the planet is old in a way that blurs comprehension. 4.5 billion years is not a story. It's a landscape of time. For the majority of that span, there were no humans, no mammals, often no life on land at all, only microbes, oceans, and chemical weather that took centuries to notice and eons to complete. In this context, survival itself is a statistical miracle. To leave any mark that lasts more than a geologic moment, conditions must align: rapid burial, mineral replacement, gentle pressure, and a long vacation from heat, ice, and tectonic stress. Mountains rise and peel away, seas arrive, lay down lime and the dust of distant deserts, and recede. Plates dive and melt. Crust is recycled like paper in a mill with no closing time. On a planet organized around change, the persistence of evidence is not assumed. It's rare. So ask the question again with that horizon in mind. If an intelligent species came and went, what are the odds its cities or tools would ride out the churn? Low, unless some fraction of their world slipped into a protective pocket, an anoxic lakebed, a deep cave sealed by collapse, a sudden blanket of volcanic ash. Even then, we'd need the layer later lifted, tilted, and exposed in just the right way for someone to notice. The further back we look, the fewer such pockets remain. Deep time is less a library than a weathered shelf with a handful of pages left. The planet's eraser has many tips. Weathering is the everyday one. Rain that filters acids through rock, roots prying apart concrete, freeze and thaw, repeating until edges round and walls sigh into rubble. Sedimentation is quieter but relentless. Dust, pollen, ash, shells and plankton, snow drifting down, stacking, compressing, turning to stone that remembers particles but not plan. Then come the editors with strong opinions. Rivers that meander and slice their own archives. Ice sheets bulldozing continents clean, volcanoes painting fresh pages, deserts migrating like slow storms. Above all is plate tectonics. the global conveyor. Oceans are born at ridges and die in trenches, seafloor ages out, and subducts back into heat. The average oceanic crust is younger than many dinosaur bones. If someone built along long drowned coasts, most of that canvas is now down to our subduction zone. Continents last longer, but they too are resurfaced, folded, faulted, and planed. Even impact scars fade, gravity flattens, weather rounds, and sediments quietly tuck everything in. The record we study is stitched from survivors and happy accident. We call the missing sections unconformities, polite geologic language for the chapter fell out. All this matters because we're tempted to assume that absence is definitive proof of nothing. It isn't. Non-preservation is the default. Any persistence is the exception. If we're going to look for someone before us, we must change our expectations. Don't expect architecture. Expect chemistry. Don't expect statues. Expect signals. Not grand avenues, but thin lines in mudstone where something global and fast disturbed the planet's routine. The Earth forgets nearly everything. Our task is to ask what kinds of things it grudgingly remembers. So let's try a careful thought experiment. Suppose somewhere between dinosaur dawn and dinosaur dusk, say 200 million years ago, intelligence bloomed. Not necessarily bipedal, not necessarily land-based. Perhaps a coastal forager with complex social learning, perhaps an aquatic lineage with tool use we wouldn't recognize as such. Maybe their technology was biological, woven, fermented, grown, materials that served beautifully in life and disappeared almost immediately in death. Maybe they organized, stored knowledge, altered landscapes, and then as climate shifted or luck failed, dwindled and vanished. Our bias is to picture metal, masonry, and writing carved into stone. But civilization is better framed as sustained complexity. Surplus, specialization, long-term planning, externalized memory, intentional environmental change. Those can exist without smelting a gram of ore. They can also leave few durable traces unless paired with stone, ceramic, or weird chemistry. Consider how human variation already tests our assumptions. Some early urban places had no streets and no doors, rooftop entries over honeycomb homes. Some cultures encoded history in song lines and knotted chords, not tablets. If that diversity exists within 10,000 years, widen the window to 10 million, and the space of possibilities expands into forms we can't easily imagine. The key, then, is not to hunt for familiar silhouettes, but to look for patterns that nature rarely makes alone. Repeated geometries and deposits, geographically synchronized anomalies, odd materials that show up together across distance. Intelligence scales differently than tides and volcanoes. It clusters, networks, accelerates, and sometimes collapses abruptly. If a prior wave of minds rose and broke, the crest would look like a brief global disturbance and a long fade into normal. The fossil record is our favorite lens on ancient life, but it's a selective one. Most organisms are recycled before mineral replacement has a chance. Even when bones make it, they're often partial, crushed, or scattered. Context erodes, layers tilt, timelines blur. We reconstruct worlds from fragments because fragments are what survive. Tools have a similar problem. Stone persists, but only if shaped, used repeatedly, and buried kindly. For a long time, even obvious flakes were dismissed as just broken rocks, until patterns, repetition, wear, polish, clustering forced a reappraisal. Metal helps us leave loud signatures, yet metals prefer chemistry's company. They corrode back toward equilibrium. Without maintenance, steel skeletons become orange dust, copper greens and flakes away, aluminum pits and powders. Plastics feel durable in daily life, but sunlight, oxygen, and microbes chew them towards smaller and smaller pieces unless they're shielded in cold, dark, low-oxygen sediment. Writing is worse. Language is vapor unless carved or fired. Taken together, the biases are clear. We mostly find the lucky, the buried, the mineralized, and the recently exhumed. That means a civilization leaning on organics, fiber, wood, resins, and living materials could thrive for millennia and still ghost through our record. Even fire, the ancient multi-purpose tool, blurs into nature. Hearth charcoal and wildfire charcoal look similar without surrounding order. So when we say we've never seen evidence, we often mean we haven't seen the particular kinds of things that tend to survive. It isn't pessimism, it's inventory management. If we want a fair search, we should weight it toward the signatures most likely to outlast the churn: isotopes, synthetic molecules, mineral oddities, and peculiar, repeated disruptions in the slow background of sediment. In 2018, climate scientist Gavin Schmidt and astrophysicist Adam Frank posed the question professionally: if an industrial civilization had existed deep in the past, could Earth's sediments reveal it? They nicknamed the idea the Silurian hypothesis, a playful nod to old sci-fi reptiles. But the exercise was sober. Identify durable global markers of industry. Start with carbon. Burning fossil fuels leaves a distinct isotopic fingerprint, a rapid planet-wide shift toward lighter carbon as ancient organic stores return to the air and sea. Pair that with simultaneous changes in nitrogen from fertilizer, ocean acidification, and a spike in certain trace metals, and you begin to outline an era that doesn't look like slow geology. Add genuinely synthetic molecules, polymers, fluorinated compounds that nature doesn't make in bulk, and the case strengthens. Layer in fallout isotopes from fission or fusion, even if only as fleeting hints locked in stable archives, and the line sharpens further. But ambiguity is stubborn. Volcanoes can mimic some carbon and sulfur patterns. Methane bursts can drive fast warming. Impacts scatter exotic elements. The trick is concurrence, multiple independent signals, globally distributed, arriving abruptly and fading on the scale of centuries to millennia. That's how intelligence would likely appear in stone, not as statues, but as a thin, weird layer where several unlikely things happened at once. The hypothesis doesn't claim a prior civilization exists. It forces us to ask what evidence would count if one had, and, equally, what evidence we ourselves are laying down right now. In learning how to recognize us in rock, we learn what they, if they were real, would need to have done to be visible at all. Turn the lens on the present. Our species is busy writing a geologic footnote. Carbon dioxide and methane are climbing with a speed unmatched in recent millions of years. Oceans absorb heat and shift their chemistry. Oxygen levels change in certain waters. Acidification nudges shells and reefs. We've spread nitrogen compounds over continents, brightened soils with phosphates, and reallocated biomass. Fewer big wild things, many more of a handful of domestic ones. We manufacture entirely new minerals: cement hydrates, fly ash glass, smelter slags, pigment crystals. We've dusted the planet with microplastics that ride winds, rivers, and currents into snows, sands, and abyssal muds. And for a brief blink, last century, we salted the globe with radioactive isotopes no thunderstorm, volcano, or algae bloom could make. None of this is an opinion. It's a layered, measurable imprint. Sometime far ahead, a core pulled from a lakebed or ocean floor might show a knife-thin band where several needles move at once: carbon, nitrogen, heavy metals, novel compounds, a blip of radiation. If those cores are compared across basins, the timing will match within decades. A signature of networked activity. The built world won't fare as well, Buildings are maintenance masquerading as permanence. Stop the upkeep, and entropy collects its rent. Glass clouds and shatters, rebar swells, bridges corrode, roads crack and vanish beneath roots and dust. Satellites die, deorbit, and burn. A few far travelers drift until drag catches them, but physics is patient. What lasts best is not the skyline, it's the chemistry. That's the hard lesson and the useful guide. If minds rearrange a planet, the planet records the rearrangement more faithfully than it records the mind. The sea is a superb dissolver of secrets. Coasts lure settlements, mild climates, easy trade, rich food webs, and then move the goalposts. During the last glacial lowstand, broad continental shelves were dry plains. As ice retreated, seas rose more than 100 meters, migrating shorelines inland, drowning rivers and relocating deltas. The drowned edges became mobile archives. Waves abrade, currents sort, burrows churn, microbes digest. Salt loves metal, storms love geometry. Stone walls become tumbled ridges, then ordinary rubble. Unless quickly buried in quiet, low-oxygen mud, coastal works don't keep their shapes for long. Even the seafloor, which feels ancient, is young by continental standards. New basalt forms at ridges, old crust slides down trenches. Average oceanic crust wouldn't celebrate a 200 millionth birthday. Whatever was built on island arcs or shallow shelves is unlikely to survive intact. That doesn't mean oceans remember nothing. They keep chemical diaries, fine layers of plankton ooze, dust, ash, and silt that trap global signals. In those quiet basins, you can read abrupt warming, trace metals from faraway smokestacks, fallout, and polymers drifting down like synthetic snow. But chemistry is a chorus. Nature sings many parts, and interpretation demands context. If a maritime civilization poured wastes into seas or mined nodules at scale, you might infer it not from foundations, but from synchronized anomalies. Rare earth spikes out of proportion to volcanism, polymer residues locked in sap repels, consistent perturbations to nitrogen and oxygen cycles over a short interval. Those are hard to collect, easy to debate, and entirely consistent with how minds would show up underwater, more as altered gradients than as ruins with corners. What, then, actually resists the eraser? Ceramics and glass do surprisingly well. Chemically stubborn, they often outlive the buildings that use them. Certain concretes mineralize and strengthen, though without protection, their shapes collapse into lumps that look like odd limestone. Some synthetic molecules may persist if entombed cold and dark. Isotopic ratios, once shifted globally, become timestamps baked into carbonates, shells, and cave drift. Even when plastics fragment, their polymer fingerprints can survive as inclusions, and technogenic minerals, steel plant spherules, fly ash microspheres can be trapped in sediments as little beads of intent. Deep underground works, sealed and stable, might last longest. Tunnels, repositories, carved chambers, but empty space is hard to date, and geometry alone can be ambiguous when stone flows and breaks across ages. Mines advertise themselves in another way. Spoil heaps and tailings change local mineralogy. Drainage alters water chemistry. Certain trace elements accumulate in ratios biology wouldn't choose. Agriculture leaves quieter marks, phosphate-rich soils, charcoal-laden earths. Pollen shifts toward a few domesticated species. In Amazonia, dark earths whisper of long management, not untouched wildness. Yet even these signs blur with time, blending into natural mosaics. Unless there's repetition over distance, the lesson isn't that nothing lasts. It's that the durable things rarely tell stories on their own. You need ensembles, clusters of unlikely signals that arrive together, persist briefly on geologic scales, and then fade. That's a civilization's fossil, not a statue pointing at the sky, but a layered cord in mudstone saying something changed everything for a moment. Imagine a future geologist unrolling a core and pausing at a paper-thin stratum. Below it, the planet hums along in patient cycles. Above it, the sun. But in that slice, carbon skews light, nitrogen does a strange dance, tiny glassy spheres and industrial ashes nod hello polymer crumbs, dot the matrix, a soft radioactive tick marks a mid-century blink. There are fewer big shells, pollen diversity dips. The whole thing feels rushed. They won't see cities. They won't hear our languages. They'll infer an event, fast, global, entangled. They'll debate causes, volcanism, orbital weirdness, biotic feedbacks. And then one of them will ask, could minds do this? That's the frame we carry backward when we wonder about predecessors. If someone came before, their line in stone would likely look like ours. A brief, synchronous disturbance drawn in isotopes and residues. The rest, architecture, music, humor, grief, would be gone. This recognition isn't bleak. It's clarifying. It tells us where to look and how to listen. Not for Atlantean boulevards, but for thin chords where geology briefly plays an unfamiliar tune. It also puts our own moment in scale. We are writing a page that will compress to millimeters, maybe less, and yet it will be legible to anyone with the patience to core, to measure, and to ask immodest questions gently. If we want to find others, we must become better readers of this kind of page, more comfortable with subtlety, and more at peace with the idea that proof, if it exists, might feel like a whisper carried in stone. What counts as a civilization if we step away from skyline bias? Archaeologists usually point to patterns rather than props. Sustained settlements, division of labor, stored surplus, long-distance exchange, shared symbols, and some form of external memory, ritual, record, or root that outlives a single lifetime. Those traits appear in many costumes. Some places stacked stones into monuments. Others braided memory into song and season. The thread is continuity, coordinated effort extended through time. If we're searching deep time, we should expect the pattern before the paraphernalia, geometry that repeats where nature rarely does. Materials found together across wide distances in unlikely ratios, abrupt, synchronized shifts in chemistry that suggest a network acting at once rather than scattered accidents. There's humility here. We are excellent at recognizing ourselves, less skilled at recognizing intelligence that solves different problems with different tools. A woven city leaves little when the weave unravels. A ceramic-poor culture denies us shards to argue over. A people who value impermanence may preserve their world at the cost of being preserved within it. Still, complexity leaks signals. Food webs bend, soils change, fire grows orderly, edges between habitats sharpen or blur by design. In the absence of obvious artifacts, we can watch for these second-order signs, the choreography of landscapes, and because coincidence is persuasive, we lean on ensembles, multiple unlikely things arriving together, fading together, appearing together across faraway archives. Minds coordinate. Volcanoes do not calibrate across oceans. That distinction, gentle but real, is our compass. It keeps us open to forms unlike our own, while insisting on discipline. No single shard, no lone anomaly, no charming story will do. The planet is noisy. Civilization, if it visited earlier, would have to sing in harmony across places and proxies before we should believe we've heard it. Bias is the quiet current beneath every expedition into the past. We tend to elevate the visible, the durable, the familiar. We downplay what doesn't fit the cabinet. Early stone flakes were once dismissed as geofacts. natural breaks with suspicious angles until repetition and wear told a clearer story. The same risk shadows any hunt for pre-human complexity. If we expect chisels, we overlook twine. If we demand metal, we miss mastery expressed in fire, fiber, clay, or seed. There's a statistical bias too. Rare events, like preservation, demand larger samples to be seen. Our sampling of Earth's crust is laughably small. We drill a few cores, scrape a few cliffs, and write global histories from slivers that fit in backpacks. The right response isn't cynicism, it's calibration. Ask, what would be overrepresented if an ancient civilization existed? Not sculptures, we've covered that, but stacked coincidences. A cluster of lake beds, far apart, that show the same century-scale chemical swing, a worldwide pulse in trace metals that doesn't match known volcanic intervals, technogenic microspherules, or polymer residues appearing globally within a narrow depth. Then test the nulls. Can microbes, impacts, or orbital wobbles produce the ensemble? If yes, return to patience. If not, widen the survey and invite more proxies, pollen, magnetic minerals, rare isotopes, biomarkers that nature rarely mass produces, and guard against wishful thinking by favoring disconfirmation. Hunt for places the signal should be and isn't. Minds leave edges. Edges can be mapped. In all of this, language matters. Unexplained is not code for civilization. It's a lamp over a table where more measurements belong. Curiosity sits, rigor pours the tea, and both agree to leave the door open while the weather changes. Geology speaks in layered accents. Grains, colors, isotopes, and a faint magnetism of ancient lavas. Cores from lake bottoms and deep-sea mud are its diaries. Narrow and faithful. Each millimeter can hold a decade, sometimes a year of quiet bureaucracy, dust counts, shell fragments, soot, pollen, and the chemistry of water as it once was. Oxygen isotopes in shells tell temperatures, carbon isotopes tell about sources and cycles, nitrogen whispers of fertilization and food webs. Volcanic ashes serve as page numbers, instantaneous stamps we can match across continent. Even Earth's magnetic field, which drifts and flips, leaves orientations in tiny minerals that later act like timestamps and compasses combined. These tools let us spot the unusual, a warming spike too fast for orbital cycles, a black layer rich in soot and industrial-looking spheres, a jump in metals timed across basins. The trick is integrating many quiet signals into one coherent sentence. One core is anecdote. Several, spread widely, become chorus. If the same abrupt anomalies arrive in African rift lakes, Arctic shelf muds, alpine varves, and tropical peat, you've likely captured a planet-wide event. Then the question shifts from did something happen? What could do this? And how quickly? Natural candidates have fingerprints, impact scatter iridium and shocked quartz, volcanoes send sulfur and mercury, methane surges leave distinctive carbon shapes. Industry has a palette too. Lighter carbon from ancient fuels, nitrogen from fertilizers, odd fluorinated molecules, and minerals birthed by smelting and combustion. Deep time blurs edges, but the combination still matters. When multiple independent proxies hum the same short, strange melody, we've left the realm of coincidence and entered the realm of causes. That's where the search for others should live, in harmonies, not headlines. Ambiguity isn't the enemy, it's the medium. Consider ancient heat waves like the Paleocene-Eocene thermal maximum, rapid warming, ocean acidification, restructured ecosystems. The rock remembers that event as a thin, world-spanning smear of altered carbon, changed clays in biotic turnover. No factories existed then, yet the layer echoes some of our modern signals. Nature can at times look eerily industrial. So the discriminator becomes timing and concurrence. Minds create global changes with tight synchronism because networks outpace currents and winds. Volcanism, by contrast, often pulses regionally or in bursts tied to mantle rhythms. Impacts are instantaneous but carry distinct debris. Microbial methane can be swift, but it tends to bloom with ecological hints different from smokestack chemistry. Our job is to build tests that break our favorite answers. For any candidate anomaly, ask 5 hard questions. Is it global within dating precision? Is the onset rapid relative to background? Do multiple independent proxies agree? Can known natural mechanisms reproduce the ensemble without special pleading? Do unlikely compounds appear, things nature rarely mass produces? Only when most answers point away from the usual suspects should we float the idea that minds were involved. Even then, the claim remains provisional until more cores, more sites, more methods converge. It's slow work by design. Deep time is patient. Our interpretation should be too. The reward for caution isn't merely avoiding error, it's clarity when the rare, stubborn signal finally stands alone. If intelligence did bloom before us, its record will look like a brief planet-wide chord played on many instruments at once. Anything less is probably the Earth doing what it does best, changing itself beautifully without assistance. Let's return to the coasts, the perennial stage for complexity and the planet's most restless border. Shelves that were grasslands become bays, deltas leap sideways, barrier islands walk alongshore like unhurried travelers. Underwater archaeology shows how quickly stories tangle once submerged. Beams turn to lace, bolts fuzz into oxides, carvings surrender their edges to lime and life. The practical challenge is coverage. We've mapped great arcs of seafloor in broad strokes, but resolution varies, and the buried Holocene landscapes that matter most are draped in meters of silt. Even when sonar hints at geometry, nature is a talented mimic. Basalt columns form hexagons, currents etch straight furrows, slump blocks stack into terraces with suspicious right angles. Proof demands context, artifact scatters, tool marks, materials incompatible with geology, or layered sediments that frame a human interval between undisturbed beds. Push the window back millions of years, and the shelf you care about is gone, recycled at a trench, or swallowed by a new origin. What remains, again, is chemistry. Shelf muds and slope drifts sometimes hold annual or decadal layers. Iords can trap exquisite sequence. If mines once crowded an ancient shoreline, their wastes and smokes might be smeared across such quiet basins as altered carbon, odd polymers, or heavy metal ratios out of harmony with volcanism. It's an unromantic hunt, no marble avenues, only graphs and grains. Yet this is where coasts speak most clearly across ages, not in shapes but in synchronized stains. To hear them, we need more cores from forgotten shelves, better dates, and an acceptance that, in the ocean's archive, the loudest monuments are chemical and thin. Inventory of the stubborn, ceramics, glass, certain concretes, slag, fly ash spheres, furnace clinkers, pigments with peculiar crystal habits, and synthetic polymers sequestered from light and oxygen. Add isotopic time signatures, carbon, nitrogen, sulfur ratios locked into shells and speleothems, and anthropogenic minerals cataloged by mineralogists who now speak of a technosphere mingling with the lithosphere. Even so, most artifacts degrade toward anonymity. Shapes collapse. Compositions weather, context scatter. That's why strategy matters more than luck. A serious search for ancient industry would look like this. Define a short list of diagnostic markers e.g. simultaneous data 13C decline, day 15N increase, microplastic-like residues, spheroidal carbonaceous particles, specific fly ash morphologies, unusual fluorochemicals, compile global core libraries spanning multiple basins and latitudes, harmonized dating through tephra and paleomagnetism, pre-register hypotheses to corral bias and test for worldwide synchronicity within narrow windows. Negative controls are essential. Sample pre- and post-interval layers to toe contrast and interrogate regions where natural analogs should dominate. Large igneous provinces, anoxic events, impact horizons to ensure we're not recapitulating known signals with new names. If the ensemble appears in one basin, its weather; 2, its regional; 5, far-flung archives in lockstep, and you have the beginnings of a case. Alongside chemistry, scan for technogenic textures, perfect spheres from combustion, angular glass from quenching, pigments with industrial particle size distributions. None of these alone proves minds. Together, they constrain natural explanations to implausibility. The beauty of this approach is its fairness. It's tuned to find us as well as them, humility built in. If we cannot reliably detect our own century in mud a million years hence, our chances of finding anyone else's are lower still. Stories travel where ruins cannot. Flood myths, skyfire myths, tales of islands that sank and ages that ended. These appear across cultures that never traded goods, only weather and wonder. Most are symbolism stitched to memory. Yet sometimes the stitching aligns with geology: sea level rise after ice retreats, ash-darkened summers, coastlines redrawn within a lifetime. Oral tradition can preserve landscape truths for surprising spans when anchored to ritual and place. None of this is licensed to swap epics for evidence. It's a reminder not to discard human memory as useless noise. Myths compress, exaggerate, and fuse events, but they also point toward categories of experience that mattered enough to repeat: water coming where land once was, fire arriving from above, a darkness that lingered, knowledge lost and later relearned. If a prior civilization brushed ours only through inherited story, echoes without artifacts, the most we can do is treat convergent motifs as gentle prompts. Look closer at submerged plains of old river mouths. Re-examine lake cores near sites tied to persistent deluge legends. Date dune migrations that local songs mark as borders shifting. Sometimes skepticism and respect can share a table. The scientist's task is not to baptize myth as data, but to allow myth to suggest where data might be hiding, especially when the sought-after traces are faint. In the end, rocks must speak, yet stories can tell us which rocks might have tongues. And for a sleepy mind listening in the dark, there is comfort in this. Even when the earth forgets, people try to remember, and that instinct itself is part of the signal we leave for whoever listens next. Now to the curiosities. The out-of-place tales that orbit museum basements and newspaper clippings, machine shapes in stone, metal spheres in ancient layers, chains in coal, footprints beside trilobites, nearly all collapse under scrutiny, mixing of strata, intrusive artifacts, natural concretions, hoaxes, too earnest to be clever. Yet the category they inhabit serves a use. It forces method. If you think something shouldn't be there, you test 4 pillars. Context: was the layer sealed and undisturbed, with clear stratigraphy above and below? Provenance: is the chain of custody intact from discovery to lab bench? Multiplicity: are there independent finds of the same kind in equivalent layers elsewhere? Mechanism: can geology plausibly scope the object without intention? If any pillar fails, skepticism wins, and typically it does. But suppose one day a stubborn object remains, composition alien to its host rock, microstructures impossible to mimic by slow chemistry, found at multiple sites of the same age, each with airtight context. Even then, one artifact is a question mark, not a sentence. You would go hunting for its siblings in cores, in quarries, in thin sections scanned by indifferent machines. You would expect accompanying signals because minds leave ecosystems and chemistries askew. Until that ensemble appears, the out-of-place remains what it mostly has been, a mirror for our hopes and a rehearsal for our caution. Practiced caution is not a mood, it's a technique. It's how you keep wonder alive without letting it write checks that measurements cannot cash. Imagine a civilization that never loved metal. It grows what it needs: beams from bamboo groves, fibers from plants engineered by patient selection, glues from resins, colors from earth and beetle shell. It navigates by stars and swells, counts with knots, writes with smoke and song, domesticates fire to sculpt landscapes into mosaics of food and refuge. Its waste is edible by forests. Its machines die as compost. Its monuments are seasonal, fields that flash like constellations, orchards tuned to bloom in sequence, fires set in spirals to renew soil and guide grazers. Intelligence here is ecological choreography, not extrusion. 1,000 years after its last festival, only soil knows phosphates higher than chance, charcoal laced through dark earth, pollen curves that show a few plants made unusually common, then gently receded. 10,000 years later, rivers have meandered new braids, dunes have walked. The signal blurs but does not vanish entirely if the land stayed quiet. 1,000,000 years, and you need miracles. A collapsed storage pit sealed in clay, a cave floor layered with fibers that mineralized, a paleo lake bed that sifts and saves every season's dust. The possibility isn't sentimental, it's practical. Complexity does not require smokestacks. It requires memory, cooperation, feedbacks, patience. Such a culture could be advanced in every measure that matters to its members and still opt for light footprints that deep time erases. Our detectors trained on masonry and metal must adapt to hear choreography. Terra preta taught us once. Ancient fire regimes teach us still. If minds chose to blend, their legacy would be gradients, not statues. And gradients need many measurements before they resolve into intention. Soil is an interface, not a surface, half life, half rock. A slow conversation between root and mineral. It remembers in smudges a hearth as a blackened lens, a home as phosphate and fats, a buyer as nitrogen and trampling, a garden as crumbs of charcoal, seeds, and a texture that stays loose where feet once softened it. Geoarchaeology reads these hints with cautious eyes because fires fall from lightning too, and animal colonies enrich ground without asking anyone's permission. Over centuries, plow and rain remix. Over millennia, dunes, floods, and loess bury and blur. After long ages, only unusual kindness preserves a profile, a bog that stains and seals, a cave drip that armors floors with calcite, a landslide that tucks a village into anoxic sleep. If the question is millions of years wide, soil alone won't carry it. Yet soil is where signals start, charcoal rises to chemistry, nutrients bleed to basins, dust becomes distant layers. Reading deep time is largely reading what soil exported. That's why we chase cores and speleothems. They are soil's letters mailed to lakes and caves, stamped with dates. If we ever meet a layer that whispers of coordinated hands, carbon lightened in a hurry, nitrogen nudged, technogenic beads, sprinkled like punctuation, polymers muttering in the background, we'll owe that discovery to soil's first faint notes. Until then, we practice listening. we refine patience. And as you drift tonight, it helps to remember the earth is always writing, but in a slow script. Minds are quick to see them in stone. We need both tempos at once, the hush of sediments and the suddenness only living intention can make. Picture the afterglow of our absence in fine detail. A year in, pumps fail and subways fill. 10 years, glass crazes and falls. 50, roofs break, rain eats iron, vines thread rebar. In a century, forests retake avenues. In 3, most skylines have settled into low hills of rubble. The archive that endures best is the quiet kind. Silt layers in city ponds and reservoirs, storm deposits in estuaries, dust laminated in attic-like corners of abandoned basements where water didn't reach. Those pockets trap technogenic grit, fly ash spheres from burned coal, metallic flakes from breaks, microscopic rubber pigments with lab-straight crystal habits. Deeper still, landfills become accidental museums. Oxygen starves, temperature stays low, layers compact into a polymer and shard rock that future quarry workers might slice like a strange conglomerate, yet even those museums are parochial without chemistry's chorus elsewhere. This is why future readers would rely on cores, not monuments. They'd pull mud from far lakes, peat from bogs, ooze from abyssal plains. In each, they'd mark a razor-thin interval where signals stack, lighter carbon, fertilizer, nitrogen, fallout isotopes, a blip of mercury from industry, and a pollen crash, as wild mosaics gave way to monoculture, then partly recovered. Interpreting intention from such evidence is delicate, but intention leaves a rhythm, abrupt onset, global concurrence, and linkages among otherwise disconnected spheres, air, water, soil, living biomass, changing together. The longer we imagine their reading of us, the better we learn where to listen for anyone else. Not in cathedrals of stone, but in synchronized whispers across distant sediments. If we learn that grammar well, we'll either meet predecessors in a line of rock or accept the deeper humility that sometimes minds pass like meteors, brief, bright, and known mostly by the thin glass they leave behind. Let's move downward, beneath foundations and roots, into places that ignore weather. Subsurface voids are conservative archivists, mines, tunnels, caverns, sealed repositories. What they lack in romance, they repay in preservation. In caves, slow drips, right thin calcite laminae, dust and soot from surface worlds become time-stamped inclusions inside transparent stone. Speleothems remember forest changes, rainfall chemistry, even distant fires when smoke found its way into sinkholes. If intelligence once lived lightly, caves might still catch its breath. Rare organic residues protected by carbonate, faint polymer traces, or aerosol-borne particles trapped between growth bands you can date by uranium series clocks. Deeper engineered spaces could last longer. A carved chamber, tabular and clean, may survive collapses as a void bounded by unnatural flatness. Yet geometry alone is fickle. Rocks flow, faults slip, and over geologic time, even crisp walls become softened puzzles. The stronger clue is assemblage. Unusual minerals on surfaces, fly ash, beads, paint pigments, corrosion products with industrial stoichiometry, or layered dust that spikes in metals improbable for local bedrock. Consider repositories designed to be noticed, message stones humanity has mused about for nuclear waste, engraved warnings, symbolic fields, engineered ceramics stable for 1,000,000 years. Their ambition exposes a truth: we cannot count on language, we must count on physics. Durable shapes, stable minerals, and patterns robust to culture are the only tongues that cross such spans. If someone before us sealed memory underground, a fair search asks, in return, Where are the oldest stable regions? The cratons with low heat flow and little deformation? Where are caves that accrete steadily with minimal flooding? Where do fault maps say, here time has been quiet? Search there for the quietest dust and ask it what drifted through from worlds above. Deserts give preservation a different stage. Aridity halts decay, pauses corrosion, and leaves wind as the chief editor. In hyper-arid basins, ancient hearths can sit nearly as they were left. Footprints last for years, wood mummifies, salts bloom but also encapsulate. Salt flats, especially, are chemical pantries. Brines concentrate elements, then crystallize, trapping aerosols and microdebris like snow pressed into ice. Salt flats in aerosols and microdebris like snow pressed into ice. It incorporates airborne materials slowly, like a time-integrating sponge. Scratch it, and you write a short-lived message. Analyze it, and you read a long one. Elemental ratios, isotopes, even microplastic crumbs, if present, could embed. Dunes move, yes, but lee-side interdune ponds can store fine layers. Desert caves and lava tubes stay cool and still. Meanwhile, polar deserts, Antarctica's dry valleys, hold cold archives where organics degrade very slowly. There, wind-stripped soils and lake ice moats capture far-traveled aerosols without the biological churn that blurs signals elsewhere. Deserts also challenge us. Geometry is unreliable, sun bakes and cracks, salts deliquesce, then recrystallize, fracturing what they once preserved. The answer is redundancy. Sample many sites across a basin and test for coeval anomalies. The same brief surge in specific trace metals, unlinked to source rocks, an odd fluorinated compound, or polymer fragments, co-occurring with a carbon isotope nudge. If several far dry places hum together, your chorus may be civilization's echo, and if you find nothing but wind's poetry, you still refine the map of where Earth keeps secrets and where it lets them blow away. Ice speaks clearly until it flows. In glaciers and ice sheets, snowfall stacks into annual bands through which trapped air, dust, ash, sea salt, and industrial tracers can be read like ledger lines. For hundreds of thousands of years, Greenland and Antarctica have stored such records. Bubbles preserve prehistoric air, sulfate layers track eruptions, lead and mercury betray Roman smelters and modern petrol histories. But deep time outruns even ice. Flow stretches, folds, and eventually melts layers at the base. Subglacial water flushes. The oldest ice we can sample is limited on Antarctica, perhaps 1,000,000 and change in the best blue ice areas under specific topography. If we hunt for signatures tens of millions of years old, ice won't carry them. Yet ice-adjacent archives might. Subglacial lake sediments, shielded for long spans, can accrete finely. Proglacial lakebeds down ice from steady outlets, trap whatever the ice conveyor delivers, dust from continents, smoke from fires, and any global anomalies drifting through the sky. Permafrost is another custodian. In high latitudes, frozen ground locks organics, soot, and microdebris for tens of millennia. As climates cool and warm, permafrost advances and retreats, but in stable zones, it can be a freezer of faint signal. Even where ice fails the deep time test, it teaches the method date precisely, read multiple proxies, anchor interpretations with known events, and watch for abrupt global concurrent. An older planet-wide marker, if it exists, must appear in the places that mimic ice's fidelity. Laminated lake muds with varves, hemipelagic drifts that settle gently, stalagmites with clean, continuous growth, and low-energy basins with minimal bioturbation. We learn from ice how to listen elsewhere. It's a metronome we can't carry back far, but whose beat we can imitate with rock and mud. Not all crust is equally forgetful. The ancient shields, cratons in Canada, Brazil, Africa, Australia are tectonic elders, thick, cool, and comparatively quiet for billions of years. They don't subduct, they shrug at orogenies. Erosion planes them low and broad. If a durable technosignature could nest somewhere for deep time, the margins and interior basins of such shields are plausible hosts. Paleolakes perched on cratons can persist, drying and refilling, laying rhythmic couplets of silt and carbonate that span long, calm intervals. Karst landscapes riddled with caves can accrete stalagmites for hundreds of thousands to millions of years if hydrology stays steady. Even weathered laterites on shields, iron-rich soils hardened into dewy crust, might entomb unusual particles for startling spans. Search strategies here become practical. Target endorheic basins, no outlet, where sediments accumulate and stay. Map cave systems under stable plateaus, find saprolite profiles that have barely moved since the Mesozoic. Then ask them all the same questions. Do you share a thin anomaly with the same onset and decay? Do trace metal ratios point away from local bedrock? Are there technogenic microspherules, any polymer residues caught in carbonate or clay? Shields won't preserve cities, they might preserve the smog. Another angle is impact ejecta on shields. When big rocks hit, they spatter melt droplets and vapor-condensed spherules across continents. Those layers, already famous as timelines, sometimes trap whatever was in the air that day. If an industrial interval happened shortly before an impact, the ejecta could enshrine its aerosols, a perverse but potent co-archive. Deep time is stingy. We must accept unlikely allies. A crater's glass rain might be one of them, glazing over a signal that the rest of the world quietly eroded away. Magnetism gives us a planetary calendar. As lavas cool or sediments settle, tiny magnetic grains align with Earth's field. Because the field wanders and sometimes flips, those orientations encode a barcode of polarity intervals, normal, reversed, normal again, that we've mapped globally. Pair that with ash beds of known age and with orbital pacing recorded in rhythmic sediments, Milankovitch cycles, and you can date layers with surprising precision. Why dwell on this? Because robust dating is the skeleton key. Without it, concurrence becomes coincidence and thin anomalies can't stand trial. Suppose we find a D13C drop, a D15N rise, and polymer-like residues in 5 basins on 3 continents. If each site dates the onset to the same magnetic chron within a small error and to the same phase of orbital cycles, the case strengthens. If one site lags by millennia because local sedimentation hiccuped, that's fine. Global signals smear a little in slow basins. But if differences are large and systematic, natural regional drivers, volcanoes, currents, take the lead again. Magnetic minerals also carry more than time. Their grain sizes and coercivities tell transport stories, wind-blown versus water-laid, distant dust versus nearby erosion, industrial soot and fly ash spheres often co-travel with fine magnetite. Their covariation through a layer can corroborate that we're not mistaking a storm for a smokestack. Paleomagnetism is patient. It works whether or not we like the answers. It may tell us an intriguing layer isn't synchronous after all. Good. That's how honesty looks in rock. And if one day it locks 5 far-flung anomalies into the same brief chron, we'll have earned the right to ask seriously, carefully, who else once synchronized the planet besides ice, impacts, and volcanoes? Networks are the fingerprint of minds. Rivers network too, but their branching obeys physics. Fungal webs network, but their growth follows local nutrient rule. Civilizations overlay new patterns on top, transport optimized for time, trade concentrated at hubs, signals that leap oceans faster than winds. How would that network appear in geology as simultaneous? A novel molecule synthesized in one place turns up everywhere nearly at once. A metal used for electronics surges globally despite local geology. A specific combustion byproduct appears in both hemispheres in the same decade of VARs. Even ecological signals can network. A domesticated plant's pollen shows in distant lakes without plausible natural dispersal. A predator-prey pattern shifts in tandem on separated continents. We should also look for the network's decay curve. Mines ramp fast. When they collapse or retreat, signals fall asymmetrically, sharp drop in some basins, long tail in others as sediments rework. Natural events have decay curves too, but their shapes. Volcanic sulfur spikes and then vanishes with rainout. Impacts flash and settle. Orbital force changes arrive and leave gently. A mine's curve might show policy, sudden abatement, brief rebounds, messy plateau. Those subtleties are hard to see in deep time, but not impossible in the best archives. We can model synthetic civilization signals and compare them to known natural pulses, testing which functions fit layered data best. This is less romantic than searching for buried avenues, more like statistics class. But statistics is how whispers become words. If we ever claim detection, it will be because a pattern shouted softly from many places and the shape of its rise and fall matched agency better than mantle or orbit. Minds coordinated. Coordination has a contour. Sediments, if asked well, can sketch it. There's a temptation to widen the search beyond Earth. The moon is a dead archive. Mars is a freeze-dried library. It's sensible. The moon has no weather, no plate tectonics, and its surface preserves impact gardening across eons. If any pre-human intelligence launched hardware, lunar regolith might still cradle eroded remnants, geometries softened but alloys intact. Yet this detour should augment, not replace, the terrestrial quest. Deep time on Earth is the hypothesis we're testing. Off-world checks are controls. Lunar soils do trap terrestrial dust, ejected by big impacts. In principle, they could hold a faint record of Earth's industrial aerosols if those rode out on lofted plumes, which is speculative but testable by looking for technogenic microspheres or peculiar polymers in Apollo samples from known aged layers. Mars offers stratified lake beds that remembered climates well. If prior minds engineered Earth's air or dust, a whisper might echo there too as altered deposition. Still, our first duty is to read our own rocks complete. The moon can confirm absence or strengthen presence, but Earth must speak first. The upside of lunar and Martian considerations is perspective. They remind us that permanence is contextual. What erodes here endures there. A future civilization may infer us more easily from cold regolith than from our oceans. That possibility is humbling and motivating. It tells us that if we wish to be legible to the far future, we should choose redundant archives, leave messages in stone, in ceramic, in deep caves, and perhaps in the airless dark. And if someone left messages for us, we should keep our antennas up in both places, mud for the melody, moons for the echo. What should count as a smoking gun? Not a single artifact, however charming, but a convergent suite that resists natural synthesis. Imagine discovering in a thin, globally synchronous layer all of the following: a rapid, coherent T13C decline consistent with oxidation of very old organic carbon, a D15N pattern matching synthetic fertilizer era analogs, a spike in spheroidal carbonaceous particles and fly ash glass, with morphology and chemistry tied to high-temperature combustion of fossil fuels. Traces of fluorinated organics with carbon-fluorine bonds rare in nature, microplastic-like polymer shards embedded within carbonates or clays, an uptick in certain rare earth element ratios matching ore processing signatures, and a transient signal of anthropogenic radioisotopes or their daughter products at levels incompatible with astrophysical fallout. You would date the onset and peak tightly with tephra varves and paleomagnetics, then test dozens of cores and caves across latitudes and basins. You would model volcanic impact and methane release scenarios to show they cannot replicate the full ensemble without improbabilities stacking. Only then would technology leave your lips softly. The standard is high by design. The reward is proportionate, a reframed history that inserts another verse into Earth's long song of minds. Until such a suite appears, we collect partial rhymes, refine instruments, and, importantly, publish negative results. Mapping where the signal is not is as crucial as trumpeting where it might be. Empty layers are data, they fence in fantasies and sharpen future searches. Science earns its romance by surviving its own skepticism. If one day a stubborn layer remains thin, strange, planetary, no one will need breathless headlines. The rocks will already have told a story, and our role will be to read it at gratitude and care. Humility is not a bow, it's a tool. It lets us hold two truths without cracking, that extraordinary claims need extraordinary evidence, and that deep time is a champion eraser. Between those truths lies the work, careful, repetitive, sometimes dull, occasionally luminous. The luminous part is why you're here, eyes heavy, mind idling towards sleep. While we talk about mud and memory, there is comfort in the smallness. If we are the first, then our line in rock will be a beginning. If we are not, then our line is a continuation, and that too is consoling. Either way, the method is the same. Listen for harmonies, distrust solos, date everything, and prefer ensembles that nature struggles to assemble unaided. In your own life, this translates into a slower skepticism, believe patterns over anecdotes, rhythms over shouts. The earth practices that kind of patience. Tonight, let's borrow some. Picture the core laid out on a bench under soft light, each millimeter a decade, each color a season, each tiny sphere a combustion ember cooled into glass. Somewhere in those millimeters is us. Somewhere else, maybe nowhere, maybe everywhere, is someone before. We will not force them to appear. We will keep measuring, mapping, and letting the quiet decide. And as your breath evens and the room fades, consider that this too is a form of listening, trusting a long process more than a loud moment. If other minds once watched their skies and wondered, our questions are how we shake hands across time. Sleep is simply the pause where the handshake lingers, light and real, even if we never learn the name. If we were designing a fair test for civilization in deep time, we'd start with a research blueprint rather than a treasure hunt. Step 1. Define diagnostic ensembles, combinations of signals that together are hard for nature to fake. Think of a shopping list like this. Rapid global D13C lightning D15N elevation, consistent with fertilizer analogs, synchronous spikes in spheroidal-carbonaceous particles, and fly ash glass. Traces of organofluorines or other molecules with stubborn carbon-fluorine bonds. A brief pulse of anthropogenic-style radioisotopes, or their daughters, and rare earth element ratios, suggestive of ore processing rather than volcanism. Step 2. Build a stratigraphic network. Pre-select lake, shelf, and cave sites across latitudes in both hemispheres. Demand VARBed, yearly, or near-VARBed sequences where possible, and anchor time with tephra and paleomagnetism. Step 3. Pre-register protocol. Decide in advance how signals will be quantified, how dating uncertainties will be propagated, what constitutes global within error bars, and what null models, volcano, impact, methane burst orbital pacing must be beaten. Step 4. Blind analysis, where feasible labs receive coded samples from mixed depths to reduce confirmation bias. Step 5. Publish negatives. Mapping absence strengthens any future presence claim and keeps the field honest. Finally, iterate. If an ensemble whispers from 2 basins, add 10 more. If the whisper moves with local currents rather than calendar time, revisit the nulls. This approach won't deliver marble avenues or tidy epiphanies. It will, however, produce sentences in geology's language, measured, dated, cross-checked, until either a stubborn line remains or the hypothesis retreats gracefully. That, in the end, is the romance. Not the spectacle of a statue under ice, but the quiet satisfaction when scattered numbers align and without drama suggest that for a short while the planet heard a different rhythm and wrote it down. A global core library is the library card for deep time. Picture refrigerated vaults housing hundreds of slender cylinders, alpine varves, rift lake mud, continental shelf drifts, peak columns, and stalagmites sliced into translucent crescents. Each sample is paired with a metadata passport, coordinates, elevation, basin type, sedimentation rate, bioturbation index, known tephras, paleomagnetic crons, and uncertainties on every number we dare to cite. Standardization matters. Carbon and nitrogen isotopes measured against the same references, microplastic extraction with harmonized solvents and filters, microspheral counts performed by automated image analysis with transparent thresholds, organofluorine screening using identical detection limits across labs. We also need cross-archive anchors, tie a lake's sharp soot spike to a speleothem sulfate pulse, match both to a marine core's gray layer, use a tephrid to lock them into the same year or decade. When multiple proxies sing together, we're less likely to mistake a local crescendo for a global chorus. Openness matters too. Raw spectra, counts, code, and core images belong in public repositories. Let skeptics reprocess your peaks. Let students find your mistakes. Let independent teams try to smash your favorite story with better fits to volcanic or impact models, and add spatial humility. Choose sites upwind and downwind, upstream and downstream, in both hemispheres, across climate regimes, humid tropics, dry interiors, polar margins. If an anomaly is truly planetary and fast, the onset will align across these contrasts within the clocks we can defend. Logistics aren't romantic, but they're how wonder survives error. The more we treat mud like data, indexed, versioned, reproducible, the closer we get to distinguishing a world breathing on its own from a world momentarily conducted by mind. That difference, if it exists, will be subtle, and subtlety requires an archive built to keep tiny truths from warping in warm hands. Natural analogs are our practice exams. The Paleocene-Eocene thermal maximum, PET-AM, is a favorite. 5 to 56 million years ago, carbon gushed into the system, temperatures leapt, oceans acidified, and biota shuffled. In cores, the PET-AM reads as a sharp, thin excursion toward lighter carbon, clay changes, dissolution horizons, and biotic turnovers. It mimics parts of the industrial fingerprint fast warming, carbon lightning, but flunks the rest. No technogenic polymers, no organofluorines, no global fly ash spheres with high temperature combustion textures, no brief radioisotope blip, and a longer onset than an engineered network might manage. Likewise, Deccan traps volcanism near the end Cretaceous, injected gases and metals for millennia, and marine black shales from various anoxic events show soot and organics in abundance, but their metal sweets and sulfur patterns align with mantle-derived sources. Their timing is paced by magmatic pulses, not decade-scale simultaneity across distant basin. Impacts offer abruptness. The KPG boundary carries iridium, shocked quartz, and melt spherules. Beautiful, unmistakable calling cards. But again, the chemistry screams astrophysics, not industry. Practicing on these events teaches skepticism and scale. We learn that fast in geology can still mean centuries, that soot can be natural, that carbon lightning alone is promiscuous, that an ensemble, not a single proxy, must do the lifting. It also teaches instrument sensitivity. Can we even see polymer residues in old clays? Do fluorinated compounds survive burial? What is the detection limit for technogenic microspheres in noisy soot layers? By trying to wrongly convict PTM or Deccan as industrial, we calibrate the court so that, should a truly alien to nature ensemble appear, the verdict is deserved. The past is generous with hard problems. Solving them, even when they say no minds here, sharpens our ears for the one day a thin line might whisper otherwise. Oceanic anoxic events, OAEs, are another rehearsal. During certain intervals, parts of the oceans turned oxygen poor, fostering black shales rich in preserved organics. These layers look like civilization's hypothetical smears, dark, organic, heavy, metal spiked. But OAEs wear natural uniforms. Their molybdenum, uranium, and vanadium enrichments track redox changes tied to nutrient loads and circulation, not smokestacks. Their biomarkers, specific isoprenoids and hopenese, finger microbial blooms. Mercury sometimes surges with colloidal volcanism. Sulfur isotopes swing as sulfate cycles shift. Timwise, OAEs can build over thousands of years, wax and wane with orbital forcing, and stitch together regionally before they cohere globally. That's not how an industrial network would likely write. A decade to centuries of sharp signals, near synchronous worldwide, superposed on quieter background rhythms. Still, OAEs are useful foil. They test our polymer detection in old organic matrices, exercise our ability to distinguish spheroidal carbonaceous particles from wildfire soot, and challenge our rare earth interpretation. If we can consistently separate OAE metal patterns from ore processing fingerprints or wildfire soot morphologies from high-temperature ash spheres, we earn the right to try those tools on stranger layers. OAEs also caution us about feedbacks. Once nutrient cycles tip, nature can amplify and sustain anomalies without ongoing external forcing. A prior civilization could, in theory, light the match and vanish while the system burned on for centuries. Our models must account for ignition versus maintenance. That means looking for short, sharp initiations, and onset too steep for gradual nutrient buildup, and for markers nature doesn't mass-produce, fluorinated organics, industrial pigments, alloy-borne microspherules. Practice here is practice in humility. The ocean is an inventive chemist. We should expect to be fooled often, and to get better by being fooled well, with careful records of each mistake. Biomarkers are molecular fossils, leaf waxes, sterin, hopenese, encoding who was breathing and photosynthesizing when the mud fell. Industry adds its own cohort PCBs, PFAS, certain phthalates, odd silicones, and other polymers with long half-lives in the dark. The problem is survival. Sunlight and oxygen shred many organics, heat reworks others. But anoxic clays and carbonates can entomb fragments long beyond their warranty. The trick is targeting lakebeds with rapid burial, sapropels beneath stratified seas, and cave calcites that trap aerosols between growth bands. Detection is another trick. You need mass spectrometers tuned to sniff faint tails above noisy baselines, clean labs, and honest blanks. Then interpretation. Could some exotic microbe forge a fluorinated carbon? Nature is vast, but extensive CF bond polymers at scale look unnatural. Likewise, certain pigment crystals, engineered for stability and hue, have particle size distributions and dopant ratios peculiar to factories. Even establishing a plastic layer requires care. Microplastics pervade modern muds. Old muds may hold mineral lookalikes, so we combine spectroscopy with thermal analysis and microscopy until false positives fail, and we contextualize with isotopes, plastic fragments accompanied by lightened DAD13C, elevated DAD15N, and soot spheres at the same horizon tell a more convincing tale than lonely crumbs. Biomarkers also capture absence. A civilization that deliberately lived light, no halogens, little polymer, organics that rot cleanly, might still leave a fingerprint via altered food webs, a sudden pollen homogenization, a spike in C4 grasses from landscape burning, a decline in large animal biomarkers replaced by domesticate signals. Those are softer claims and require wider ensembles. In both cases, molecules are sentences best read in paragraphs, composition, shape, size, context, and timing aligned until maybe hardens into more likely than not. Technofossils deserve a taxonomy. Begin with shaped stones born from industry, clinkers from kilns, slags from smelters, fly ash cenosphere beads, shot-peened metallic microspheres, concrete fragments with CSH gels, and glass with quench textures and dopants foreign to volcanism. Add composites, fiber-reinforced shards whose microstructures betray woven origins, pigments embedded in matrices at concentrations biology wouldn't reach, ceramic phases stabilized by elements rarely co-occurring in nature. Then define their taphonomy, how they enter sediments, how they weather, and the mineral twins they can be mistaken for. Fly ash beads, for instance, are hollow, often perfectly spherical, with smooth skins and magnetite jackets. Wildfire soot can make spheres, but their textures differ and their chemistry points to lower temperatures. Industrial glass often carries boron, lead, or rare earths in ratios that argue for recipes, not magmas. Cement products weather toward calcite and silica gels, but their pore structures linger and their trace strontium and aluminum patterns can disambiguate. We also need negative technofossils, natural lookalikes cataloged to prevent romance, spherolytic volcanic glass, diagenetic concretions with rings that mimic machining, manganese nodules with grooves that imitate tooling. A robust key would walk a thin section through questions. Is the sphere hollow? Are there magnetite dendrites? What is the key-SEC ratio? Any fluorine or boron? A dopant pairs present that rarely co-occur geologically. Taxonomy turns anecdotes into counts. Counts turn into maps. Maps, layered with dates, become stories about pulses and pauses. If a prior industry existed, its technofossils may be dust small, scattered, and few, but few is not none. The right microscope, a disciplined catalog, and a willingness to publish this as natural, not made 50 times for every this resists nature, are how we inch from pretty grains to durable claims.
Genes are archives written in living ink. Domestication leaves signatures, selective sweeps around traits, bottlenecks, haplotype structures that shout many from few. On human timelines, we see wheat, dogs, maize bent to our will. Could such curves hint at earlier minds? Deep time muddies DNA beyond 1,000,000 years. Ancient genomes are rare outside permafrost, but fossils and sediments carry proxy. Pollen assemblages skew sharply when monocultures spread. Phytoliths, silica bodies from plants, persist and can reveal domesticated morphologies. Lipid biomyar from ruminants wax and wane with herding intensity. Even in marine muds, shifts in dinoflagellate cysts, or diatom communities can record nutrient regimes altered by land use. Genetic engineering, if ever practiced, might leave bolder scars, horizontal gene transfers in unlikely taxa, codon usage anomalies, or synthetic promoters persisting in lineages. Yet evolution is creative. Natural HGT abounds in microbes. Convergent biases are common, so we demand ensembles here. Two abrupt range expansions of domesticate-like plants across continents without plausible natural vectors, synchronous declines in megafaunal signals beyond climate expectations, sedimentary DNA, citDNA snippets, if any survive, bearing barcodes that look designed rather than drifted. A subtler clue is demographic rhythm. Minds compress time where nature nudges slowly, cultivation surges fast. Lake pollen flips toward crops in decades, charcoal pulses regularize, erosion spikes then stabilizes under terrace building. Read together, these curves whisper management. A civilization that left no metal might still have gardened entire biomes. In deep time we'd glimpse it as synchronized changes in multiple lakes, flung far apart, each telling of the same plants rising and falling in concert. Genes would be the dream evidence in their likely absence. The choreography of leaves becomes our surrogate script.
Energy is the skeleton key of complexity. Minds reorganize flows, fire into food, wind into voyage, electrons into whispers. That reorganization leaks as waste heat, altered albedo, and atmospheric chemistry. In principle, climate models can invert for causes given a thin layers isotopes and microdebris, what forcing best fits the curvature of temperature proxies, volcanism, methane burp, orbital tweak, or something with a short global onset and peculiar aerosol suite. Industrial aerosols, sulfates, nitrates, black carbon dampen sunlight differently than volcanoes. Their optical fingerprints alter the balance between direct and diffuse radiation. Speleothems in tree rings, where available in younger spans, can record changes in cloudiness and light quality. Older carbonate systems may echo those shifts in clumped isotope temperatures and trace element. Geoengineering, if ever attempted earlier, could leave stranger hints. A sudden sulfur spike without mercury, volcanoes usually pair them, or deliberate calcium carbonate dusting, altering marine alkalinity. Even city albedo, bright roofs, pale pavements, acts globally only when cities spread. But that's a fragile, non-durable trace. Better are aerosols and soot, which ride winds and settle everywhere. Waste heat alone hides in the noise, unless civilization is vast. Chemistry does the heavy lift. Still, modeling matters. We can train detection on our own century, degrade the signal with synthetic burial, and test which ensembles remain legible after a million-year handicap. If our inverted forcings still point to short, global multi-proxy disturbance, the same tools are ready for stranger layers. Physics is a generous translator. It lets us read past the lost nouns, city, ship, song, and reconstruct verbs. Burned, fertilized, clouded, cooled. Verbs travel better through time. If others verb the planet briefly, models can help us conjugate their tense. Collapse is a shape. Sometimes cliff-steep systems overextended. A drought arrives, trade falters, knowledge regionalizes, and the lights go out in stages. Sometimes slow, a controlled landing into smaller scales, a cultural choice to stop chasing growth and relearn patience. In sediments, the cliff can look like a step function. Soot drops fast, metals relax toward background, fertilization signatures ebb, yet ecological upheaval lingers. Biodiversity stalls, erosion takes time to heal, the glide looks different, indicators plateau, oscillate, reconfigure as landscapes become mosaics again. Either way, minds leave asymmetries. Natural pulses, volcanic sulfur, impact spherules, slam in and decay cleanly, civilization pulses may show policy, think bands and rebounds, a quick reduction in aerosols, a brief relapse, a final taper, hard to see after millions of years, yet not impossible in high-resolution basins. Pulse press frameworks help mines deliver presses, chronic forces, land use, greenhouse gases, punctuated by pulses, wars, panics, innovations. The signature is a braid, not a spike. We can search for that braid in varred lakes. We count layers across the anomaly. Do subsignals start and stop together, or take turns? In caves, do sulfate streaks, airborne align with nitrate streaks, agricultural and with soot, combustion? Or do they part ways for a few decades then realign? That interleaving is a human tempo. It says committees met, mistakes were made, the weather briefly agreed, then ambivalence returned. Reading such nuance is ambitious, but ambition is warranted if we hope to distinguish a planet hiccuping from a society deciding. The point isn't to romanticize endings, it's to learn their contours so that if a past mind's echo exists, we don't flatten it into a single forgettable bump. We've built a scaffold, mud for memory, chemistry for grammar, physics for verbs, and skepticism for spine. From here, the search becomes both narrower and kinder. Narrow because we know what not to trust, lone curios, pretty spheres, without context, carbon shifts that natural engines can hum. Kinder because we accept the planet's talent for forgetting and our own for imagining. We keep both in the room. If a thin, stubborn ensemble exists, brief, global, multi-proxy, hard to fake, we'll meet it with methods tuned by 100 false alarms, and if no such layer appears, the exercise hasn't failed. It has taught us to read our own line better, to archive wisely, to leave redundant messages for minds we'll never meet. That perhaps is the quiet moral. Whether or not anyone came before, someone comes after, even if that someone is only rock with patience enough to notice. So let your thoughts slow to that patience now. Picture the core again, the millimeter that might be us, the millimeter that might be someone else, the long centimeters of seas and silts between. None of them are loud, none of them are in a hurry. When you breathe out, imagine dust settling on a still lake, each mote a tiny ledger entry. When you breathe in, imagine the drill rising with a cylinder of time, cool and damp and softly glittering. Somewhere in those flecks is the truth we can reach. And beyond them is a kindness to ask carefully, to listen long, and to be content with whispers. Rest in that. We'll keep reading in the morning, and the rock will keep speaking whether or not we are awake to hear. Think of planetary archaeology as a craft kit laid out on a clean table. First are the cores, hand augers for peat, piston rigs for lakes, gravity and box cores for shell. Each tool returns a slender time tube. Each demands gentleness. Keep it cold, keep it dark, keep it labeled like a love letter that must not be lost. Next come the saws and splitters to open the cores lengthwise, revealing ribbons of browns and grays. We photograph every centimeter before we touch it. We log texture, smell, shells, flecks of ash, the sheen that hints at old oils. Subsamples go to clean labs, where white suits and filtered air try to tame contamination. Field blanks travel with us. Empty jars opened when samples are opened, closed when samples are closed. Silent witnesses that tell on us if our gear or rooms shed their own chemistry. Instruments line the benches like careful listeners. Mass spectrometers for isotopes, microscopes for soot spheres and pollen, chromatographs for elusive organics, laser ablation rigs for trace metal. Data standards are taped to the wall, how to count, how to threshold, how to publish raw files so strangers can disagree productively. We pair each proxy with its nemesis, polymer detection with mineral lookalikes, soot spheres with wildfire controls, fluorinated organics with industrial blanks. The goal isn't glamour, its reliability. A single glamorous result will not carry the day. A dozen modest, reproducible signals that rhyme across basins, mics, field notebooks matter. Weather notes matter. Whether a raven sat on the core barrel matters, because ravens shed feathers and down carries modern DNA. Planetary archaeology has no heroes, just a long relay of careful hands passing mud forward. If someone left a note in the sediment, this is how we keep from smudging the ink before we can read it. Imagine the first whisper. A student scanning slides from a high mountain lake sees perfect hollow spheres, sanospheres, peppered through a paper-thin layer. Their chemistry hints at high-temperature combustion, not volcanoes. The ash fingerprint doesn't match known eruptions. The advisor shrugs. Interesting. Likely local fires. Weeks later, a collaborator on a distant plateau reports the same spheres in a layer, the same depth down, the same thickness, paired with a sudden lightening of carbon and a nudge in nitrogen. Emails turn into a shared drive, then into more cores, tropical rift lakes, an Arctic tarn, a desert playa. Everywhere the odd layer shows up within dating era, thin as a pressed leaf, loud in its ensemble, soot spheres, fly ash glass, a modest rise in mercury without the sulfur volcanoes love, minute traces of polymers that look like nothing sediment normally keeps. The team tries to break the spell. Volcanic catalogs are combed, impact horizons checked, methane burst models spun up. None fit all the notes. A cave drapery in a distant karst adds a harmony, a sulfate stripe aligned with the lake layer, tiny industrial-looking beads entombed in calcite paleo. Magnetics lock the onset into the same short crown. The group goes quiet. No press. No slogans. They pre-register an analysis plan, ship coded samples to outsider labs, and invite skeptics to choose new sites. Months pass. New cores agree, one doesn't, and the outlier is traced to a burrow that smeared layers. The whisper persists. If this were a novel, trumpets would sound. In science, caution hums. They draft a paper that says, not proof, but anomalous, global, abrupt, multi-proxy, natural explanations incomplete. They end with requests, more cores, polymer forensics, independent dating. A whisper, well-kept, can travel farther than a shout. It can also be wrong. That's why it's a whisper. False positives deserve autopsies. Take our imagined layer and try to kill it kindly. First suspect, wildfire regimes. Massive, near-synchronous burning across continents could seed lakes with soot spheres and lightened carbon. Run charcoal reconstructions. Compare sphere morphologies to known wildfire products. Wildfire soot is often solid, irregular, its chemistry signaling lower temperatures. Industrial cenospheres tend hollow, smooth, magnetite-jacketed. If morphologies mix, the case softens. Second suspect, cryptic volcanism. Could fissure eruptions leave ash-poor but metal-rich fingerprints, Deccan-like pulses, alter mercury and carbon? But they love sulfur. Our layer sulfur is modest. Tephra shards under microscopes show no matching glass populations. Third suspect, impact spherules. Those bring iridium and shocked minerals. Search thoroughly. If iridium sits at crustal background and no shocked quartz appears, the impact door closes. Fourth suspect, diagenesis. Burial chemistry creating faux polymers or spheres. Replicate extractions with different solvents. Spike blanks. Test adjacent layers. If the odd compounds vanish outside the slice and do not appear in blanks, diagenesis and contamination retreat. Fifth suspect, dating illusions. Are the layers truly coeval? Tephra tie lines and magnetic crons argue yes. Still, recheck all clocks, include uncertainty properly, and see if the pattern survives jitter. 6. Suspect analytical bias. Blind the labs. Scattered duplicates disguised as different depths. If the same layer sings through disguise, lab romance isn't the singer. When suspects linger, we tune the ensemble standard higher, require additional proxies, hard for nature to mimic, fluorinated organics, industrial pigment grains, alloy microspheres. If those fail to appear, we revise downward. Likely natural, autopsies aren't defeats. They are victories of method over desire. Each failed suspect teaches anatomy of mud, of signals, of ourselves, and if one day an anomaly survives every kindly killing, the credibility we banked in our refusals will be interest accruing on the day we finally say, carefully, perhaps. Under the hood, our caution has math-shaped bones. You don't need equations to feel it. Begin with priors. How plausible is a pre-human industrial civilization given what we know of evolution and Earth's churn? Modest, not zero. Now ask about likelihoods. If such a civilization existed, how likely is it to produce the ensemble we observe? Perhaps high. If only natural processes existed, how likely is the same ensemble? Lower, but not negligible. The update lives between those numbers. You lean toward the explanation that makes the observed world less surprising, without pretending certainty. This is Bayesian thinking with T instead of chalk. It helps us resist headline gravity and keeps could be from metastasizing into is. It also guides sampling. Where would data most change our minds? Find sites where natural hypotheses predict strong signals that the civilization hypothesis does not, and vice versa. Measure there first. That's value of information logic. Spend time where answers separate most. We can also simulate oblivion. Take our known Anthropocene suite, degrade it with models of burial, diffusion, and diagenesis, and ask which proxies remain legible after 1,000,000, 10 million years. Those survivors earn more weight in future hunts. Statistical humility doesn't sand off wonder, it preserves it by insulating it from wish. If, after careful updates, the scales still tilt toward natural, we publish that and sleep well. If they tilt the other way even a little, we gather more weight. Some will always prefer dramatic leaps. The rest of us will build a bridge of small planks, prior evidence, update, repeat. Deep time doesn't reward speed. It rewards steadiness, numbers that can sit under bright lights and keep their shape. Suppose one day the evidence tilts. How do we speak without turning a careful finding into a carnival? Communication is part of the science. First, we phrase the claim exactly. We report a thin, globally synchronous layer with an ensemble of markers X, Y, Z that collectively resist known natural explanations. We list the nulls we tried and how they failed. We put all raw data and methods out where critics can download them before the press conference coffee cools. We invite hostile review and give it a microphone. We avoid metaphors that smuggle certainty. No ancient reptilians, no Atlantis. We say industrial-like and define what we mean. Rapid global carbon lightning, fertilizer-like nitrogen, technogenic particles. Then we sketch futures. If correct, here's what should also be true: predictions. The layer should appear in these untested basins. These specific polymer residues should co-occur. This rare pigment should be detectable in calcite. We tell people where to look to prove us wrong. We also draw boundaries. This evidence does not imply time travelers, aliens, or secret human lineages. It speaks only to a brief, planet-wide ensemble that matches what minds might leave. Honesty about uncertainty is not weakness, it's armor. The public can handle nuance if we model it ourselves. Calm, curious, willing to revise. The real story remains the planet's a world that forgets nearly everything and yet can, under special kindness, keep a thread. If that thread once belonged to someone else, the appropriate tone isn't triumph but kinship. We share a page, we may never share a name. Tell it that way, slowly, clearly, with room for the possibility that we're wrong and gratitude. If later workers find the seam we missed, if we wish the far future to read us kindly, we should leave legible notes in the languages geology understands. Start with redundance. Write the same message in many media, fired clay tablets, glazed with stable pigments, sintered ceramic plates doped with elements unlikely to move, glass with etched pits and coating patterns, stone engraved deep where freeze and root can't pry. Place copies in diverse archives, arid caves, deep karst, shield cratons, polar deserts, subsea floor boreholes capped and marked in ways that persist as shapes, not words. Keep the alphabet simple, mathematics and physics motifs that any tool-using mind would rediscover, prime spirals, elemental abundances, isotope ratios, orbital periods, constants, sketched as proportions, pair symbol with example. If we warn about radiation, embed a small, stable daughter isotope ratio demonstration nearby, something measurable, self-explanatory, not reliant on trust. Consider molecular messages, polymer sequences designed to resist hydrolysis, encoding binary tapes of our explanations, packaged inside ceramic seeds. Expect vandalism by time, designed for partial survival, redundancy, checksums, error-correcting patterns, visible even if corners fracture. Resist hubris in text. Our specifics, names, borders, memes won't travel. What might a primer on proxies, how to read carbon and nitrogen, where to core, what ensembles signal minds, a map of safe archives and of false friends, natural layers that look like us, advice for kindness, how to listen without leaping. In short, a field guide to finding us and, by extension, anyone like us. If predecessors had left such a guide, we'd treat it with reverence and testing. Let's gift the same courtesy forward, not as a monument to ourselves, but as a toolkit. We can't know the reader. We can prepare the page. Imagine the Deep Time Codex, a kit we assemble and bury in multiples. Volume 1, How to Hear Us. Plain diagrams of cores, stalagmites, and the proxies we've described, with short icon-only instructions. Collect, split, measure, compare, date. Volume 2, What We Did. A sober ledger of our industrial century, fuels burned, elements moved, isotopes altered without blame or boast. Volume 3, Warnings and Kindnesses. Notes on heavy atoms, on waste that bites, on how to keep water sweet, on how to archive without words. Each volume is etched in ceramic discs, the size of a hand, stacked inside a sealed, inert canister with desiccants and getters, then nested in a vitrified clay vault. Symbols on the outer surface aren't words, they're puzzles any physicist can solve. A hydrogen atom spectrum drawn as lines, the solar system's orbital ratios, a clock built from decay chains, a simple sine wave showing Earth's day length. The vault's geometry is deliberate, no right angles in nature at this scale. We use a few deeply. We place codices in places likely to be boring for millions of years. Shield caves, hyper-arid basins, permafrost bedrock, subsea floor clays beneath deserts. We record their GPS, but also carve analog maps, constellations as angles, distances as ratios of Earth's radius, bearings as sunrise azimuths at solstices. Redundancy includes scatter. Some caches will flood, some will crack, some will be eaten by tectonics. Enough should sleep through. The goal is not immortality, it's intelligibility. We assume partial recovery and design for it with repetition and checksums, tiled patterns that scream when a tile is missing. A codex like this isn't vanity. It's a handshake extended toward whatever patience lives ahead. If no one ever finds it, we still will have taught ourselves to speak more clearly to stone. Unknowability has a kind softness when you let it sit beside you. We want clean endings. There were predecessors, or there were not. Here is the proof. Framed and lit, deep time refuses that posture. It offers us, instead, practice in living with incomplete yet widening circles of understanding. We learn to distinguish noise from whisper, whisper from word, word from sentence. We accept that some sentences will always be missing their verbs. This isn't resignation, it's attention without impatience. At night, the mind is good at practicing such attention. As the room quiets, the crude hierarchies, urgent, trivial, loud, bright, fall away, and slower priorities surface. What should endure? What can we make easier for minds we'll never meet? How do we keep our questions honest when our answers are sparse? Wonder is not a hunger to be fed, it is a muscle to be used gently and often. The planet invites that exercise. Sit with the idea that you may never know if anyone came before, and that this not knowing can still guide kinder choices toward redundancy, toward clarity, toward leaving fewer messes and better math. If their hands once held up their skies and wondered, they too felt this twin, a curiosity that keeps you awake and a drowsiness that says, rest, the rocks are patient. You can hold both. Breathe in the long, breathe out the urgent. If proof arrives one day, it will arrive through the same patience you're practicing now, and if it does not, tonight's calm is not wasted. It is a rehearsal for the scale at which the earth keeps time and the scale at which minds learn to listen. A grain of silt is a cosmos if you crouch close enough. Its edges are mountains, its shadows, valleys, its minerals, continents in miniature. We live between those scales, small enough to cup a pebble, large enough to chart a spiral arm. The question of predecessors sits right at that crossroads. It asks us to be microscopes and telescopes at once, to notice soot beads scarcely wider than a hair and to frame them inside planetary histories, to count pollen grains and feel their count quake our sense of uniqueness. It's easy to get lost. The rescue comes from rhythm. Return again and again to the practice, define an ensemble, test a null, date precisely, publish cleanly, accept correction, repeat. Rhythm makes humility sturdy. It also makes awe sustainable. Galaxies swirl without needing us, and yet we are briefly able to model their dance. Sediments settle without needing us, and yet we can read a century in a millimeter. The coexistence of insignificance and capacity isn't a contradiction, it's our address. If someone else once occupied this address, their presence does not shrink ours. It joins it. Two voices, separated by eons, both singing into stone. Maybe we'll find their harmony. Maybe we'll only ever sing solo. Either way, the work is the same. Tune your ear, keep the beat, let the melody be simple enough to survive when, somewhere a future reader, human or otherwise, or only rock with patience, will hear that melody and hum along. That too is civilization coordination, not just across space, but across time, held together by the most fragile, most resilient instrument we have, attention. Let's take stock before drifting further. We've traded pyramids for proxies, monuments for molecules, and certainty for ensemble. We've learned that Earth is an editor with a heavy hand, that preservation is the exception, and that intelligence, if it ever visited before, would likely appear as a thin, abrupt chord played across many archives at once. We've outlined a toolkit: cores, caves, deserts, shields, ice-adjacent sediments, isotopes and technofossils, biomarkers and microbeads, paleomagnetic barcodes and tephra timestamp. We've rehearsed against natural lookalikes, impacts, volcanism, anoxic events, and accepted that most anomalies will turn out to be Earth doing Earth. We've drafted a communication ethic for the day an ensemble survives autopsy, and we've imagined leaving better notes for readers we'll never meet. None of this gives us an answer yet. It gives us a way to keep asking without breaking the question. That's enough for tonight. As you settle, picture a quiet lab where cores sleep in the dark like loaves in a cool pantry. Picture a cave drip ticking calcium seconds. Picture wind placing a single grain on a lake's skin. Somewhere in those small motions, there is a ledger that will outlast us. If it holds only our line, we will have made it legible. If it holds another's, we will be ready to see it and to greet it with the mixture of rigor and gentleness it deserves. Close your eyes on that image. The planet turns under you with its old, forgiving patience. The question is not going anywhere. Neither is the kindness you can bring to it when morning comes. Dust is a messenger with a long commute. It lifts from dry lands, crosses oceans, and settles like slow snow on faraway lakes and seas. Layer by layer it builds pale blankets, lows on plains, fine laminae in quiet basins, thin veils on glacier fern. Because wind systems are planetary, dust sometimes synchronizes landscapes that near meet. A pulse of aridity in one belt can brighten sediments half a world away. A shift in storm tracks can steer grains to new shelves with calendar neatness. For our question, dust is both courier and canvas. Couriers, because aerosols sweep up whatever rides the air. Soot spheres from combustion, microscopic flakes of metal polymer crumbs, and deposit them alongside mineral grains. Canvas, because those code-delivered traces paint thin horizons that, if dated well, reveal an onset shared across continents. Loess, in particular, is underused memory. It accretes on land, often steadily, and can entomb horizons that escape bioturbation. Magnetism within Loess records wind vigor, pollen whispers of distant vegetation. Geochemistry marks the blend of source terrains. A civilization scale signal strong enough to reach the sky would hitchhike, fly ash beads, nestling among quartz silt, odd fluorinated residues absorbing to clay, a sudden lightening of carbon and organic flecks. Interpreting such layers demands caution. Dust sources change naturally as climates wobble, and wildfire soot loves the ride too, but we fight ambiguity with ensembles and geography. If the same 3 or 4 technogenic markers appear abruptly in low sections on multiple continents and line up with coeval spikes in lake varves and cave calcite, coincidence thins. Dust also helps with absence where lakes are rare and caves shy. A Loess bluff can still hold the year the air briefly wore a different chemistry. The wind keeps poor diaries, but excellent habits. We read habits, and the habits point the way. Geology names its exclamation points. A golden spike is the ceremonial pin at a global boundary stratotype section and point, the crisp horizon that marks an epoch start. Beneath ceremony sits rigor. The boundary must be isochronous. Same time everywhere, accessible, richly described, and mappable by multiple proxies. Think of it as the world's official page break. Whether or not a human-made epoch deserves such a pin is a separate quarrel. What matters for our hunt is the doctrine behind the ritual. You don't crown a boundary with one proxy, and you don't crown it where local quirks masquerade as global shifts. You crown it where many clocks agree and where future readers can return with better tools and still find the line. If a predecessor civilization had a brief industrial breath, its trace, if any, would resemble a micro-golden spike, thin, global, multi-proxy, and bracketed by datable tie points. That mental model disciplines it suggests we should search for spike candidates where stratigraphy is quietly spectacular. Varb lakes with uninterrupted calendars, stalagmites with unbroken growth, hemipelagic drifts with steady settling and sparse burring. It teaches us to distrust glamour outcrops with jagged exposure but fussy biographies. It reminds us that a spike earns its place by being boringly reproducible more than spectacularly photogenic. Importantly, the golden spike mindset keeps us honest about scale. A civilization-scale perturbation should not need a microscope to be global. It should just need a microscope to be specific. We practice by testing known page breaks, impact boundaries, anoxic onsets, volcanic pulses, and grading our instruments against them. When our ensemble can pick those loudly natural spikes cleanly from noise, we graduate to searching for quieter ones. Ceremony aside, the ethos is transferable. Choose well, measure widely, document generously, and leave a breadcrumb trail sturdy enough for strangers. Computers can learn to see what eyelids miss at 2 a.m., train a vision model on thousands of known particles, wildfire soot, fly ash, cenospheres, impact spherules, volcanic glass, and it will begin to sort slides with unhuman stamina. Couple that with spectral fingerprints, and you have a first-pass sentinel flagging grains worth human attention, counting shapes across depth, noticing patterns too diffuse for a tired grad student. But smart assistants need leashes. Overfitting is the quiet thief models that memorize lab quirks instead of planetary truth. The antidote is heterogeneity, images from many microscopes and labs, slides prepared by different hands, blind labels, and adversarial tests, where lookalikes are designed to fool. Interpretability matters too. When a model calls a bead industrial, it should point to features hollowness, magnetite jackets, surface smoothness, not simply issue a verdict. The same goes for anomaly hunters scanning multi-proxy data. Unsupervised algorithms can cluster layers by chemistry and texture, highlighting thin intervals that don't belong. We let them suggest, never every flagged horizon goes back to first principles, stratigraphy, dates, alternative causes, open opicans help, code and training sets, live in public repositories, raw imagery accompanies papers, benchmarks invite competitors to beat yesterday's accuracy with tomorrow's caution. AI's best gift here isn't certainty, it's attention scaling. It reads more slides, more spectra, more laminae than a decade of eyeballs, and it does so without caffeine or pride. That lets humans spend their limited focus on context, design, and the delicate art of saying we don't know yet. Used well, machine companions sharpen our humility. They catch whispers we'd miss, and crucially, they also generate false alarms we must learn to quiet. In both cases, the partnership practices the core virtue of deep time reading, patience amplified, certainty resisted, curiosity kept awake. Resolution is a double-edged lens. Ver's annual layers in lake mud can, at their best, resolve seasons: spring silt, summer diet, autumn organics, winter clays. In such archives, a decade is a fingernail's breadth, and policy scale changes can in principle be time, but high resolution invites illusions. A burrow the width of a matchstick can smudge 3 years into one. A slumped lamina can masquerade as 2 summers. The cure is redundancy and cross-correlation. Aligned soot peaks with independent calendars. Tephra ages, paleomagnetic wiggles, radiocarbon plateaus. If multiple clocks agree, the pattern hardens. We also mind lag. Airborne signals reach lakes quickly. Watershed-borne nitrogen may lag by seasons as soils flush, caves respond to air chemistry, and drip hydrology with their own delays. Marine margins integrate months. Abyssal plains can smear years into centimeters. When we claim synchronous, we mean within the jitter of each system, and we show the jitter. The goal isn't perfect simultaneity, it's coherent onset relative to each archive's tempo. Statistical tools help cross-spectral analysis test whether two signals share frequencies and phases. Transfer functions estimate how a watershed filters nitrate pulses into sediment. Bayesian age models propagate dating errors honestly. Practically, this means your eye's delight at matching spikes must be checked against math's frown. Some alignments are luck, others are law. Minds leave fast starts. Nature often ran. If a thin layer shows abruptness in varves, a near step in cave bands, and a short upstroke in marine mud, all within modeled lags, you've likely caught coordination. Resolution also teaches mercy. Many basins won't be perfect. A good search tolerates ragged edges and makes its case on ensembles, not immaculate sections. Deep time is a soft focus camera. We sharpen where we can, blur responsibly where we must, and avoid drawing rulers on clouds. Caves are quiet, but not mute. A stalagmite grows like a stack of glassy coins, each rim a thin report on drip water, its carbon, its sulfur, its trace metals, its dust stowaways. We can read those reports without breaking the coins. Micro-CT scans reveal growth bands and inclusions. Raman and infrared spectroscopy map organics and minerals in place. Laser ablation nibbles trace elements along a line thinner than a hair, leaving the rest untouched. Non-destructive first, destructive last. That ethic lets archives survive our curiosity. Sampling ethics matter because caves are finite laboratories. Every core hole is a hole in time we can't replace, so we plan. We map growth axes to avoid mixing years. We date outer layers before cutting deeper. We predefine how much we'll remove and why. We leave markers for future teams. We also read cave noise. Storms can flood chambers, smearing dust. Bat colonies can add nitrogen. Human visitation can leave modern carbon fingerprints. Field blanks and entrance air monitors help isolate our breath from histories. The payoff is exquisite. Cave calcite has trapped microspherules mid-flight, sealed sulfate streaks that mirror atmospheric sulfur and archive droughts and fires at seasonal scales. If a prior industry exhaled briefly, cave draperies might have caught its aerosols and fixed them into stone pages immune to later rain, and caves cross-check the sky. A lake sees a watershed, a cave sees the ceiling of air that drips through stone. Agreement between them raises eyebrows in the right way. Silence also teaches. Many cave records will show nothing unusual at candidate horizons. Those knolls are precious guardrails. They keep enthusiasm corralled and tell us where signals fade. We owe caves gratitude proportional to restraint. The slow patience with which they grow should instruct the speed with which we claim. Fields and labs are built by people, and people are trained by cultures. A good mud reader learns more than instruments. They learn walking speed, slow near exposures, slower near subtlety. They learn to write field notes for a stranger, not a future self, that will remember everything it won't. They learn to label samples as if a tired customs agent will drop the box. Someone will. Mentorship passes down small graces, packing extra caps, carrying a spare pencil, recording wind direction, asking landowners for stories. Community knowledge matter. Farmers know when ponds turn odd colors. Anglers remember black snow summers. Rangers can point to hills that burn in rhythms. Indigenous and local archives songs, place names, seasonal calendars, often encode hydrology and fire in ways maps don't. Folding such knowledge into site choice isn't romanticism, it's sampling design. Training also includes failure literacy. Students should analyze blanks that are dirty and learn the taste of contamination. They should run statistics that spit out attractive but spurious correlations and learn to shrug and delete. They should be rewarded for careful note. Ethics is curriculum, not a footnote. Data sharing norms, authorship clarity, pre-registration practice, and the courage to slow down when a result arrives too neatly. Field safety is non-negotiable. Weather briefings, comms plans, buddy systems, respect for heat and water and tired legs, and joy belongs too. A day when a core emerges smooth and perfect, when a pollen slide reveals a spring no one remembers, when a student spots their first fly ash bead, those are the sparks that keep the relay moving. We're training listeners more than diggers. The planet speaks softly and in many accents. A good listener learns to hear all of them and to know when to be quiet. Logistics is the dull poetry that lets wonder happen. Cores don't ship themselves, customs forms don't admire hypotheses. International repositories must keep samples cold, dark, labeled, and findable decades later. That costs money, patience, and standardized metadata. A global hunt for thin, abrupt layers benefits from boring agreements, which fields are mandatory on a core's passport, how to encode uncertainties, how to reference tie points, how to cite a repository's TORIAs, funding models should privilege maintenance alongside discovery. A shiny new drill wins headlines. A quietly humming freezer saves science. Collaboration reduces waste. If a team in one basin already measured D13C and paleomagnetism, the next team can focus on microplastics and technofossils, then cross-post results to shared registries. We also measure our own footprint. Field campaigns can be low-carbon rail where possible, shared shipping, solar in camps, fewer flights via longer but richer stays, permitting respects, sovereignty and science diplomacy, transparent goals, local partnerships, data return commitments, training exchanges that leave capacity behind. Equity makes the network resilient. Cores sleep better when many nations can host, many students can analyze, and many journals welcome careful, incremental work. Registered reports, where methods are peer-reviewed before results exist, protect negative findings from the graveyard. They also starve hype and feed craft. Finally, contingency planning belongs on every checklist. Storms, ground helicopters, pandemics close borders, ships miss weather windows, remote sensing, local partners, and modular plans keep momentum when the world reminds us it isn't a lab. Logistics won't find the layer. It will keep the lights on and the doors unlocked, so that when a whisper appears, it can travel legally, ethically, cold, and intact from a muddy shore to a mass spectrometer and into a dataset large enough to matter. Suppose we do find a stubborn layer and it withstands every natural explanation we can muster. What changes? Maybe less than headline writers hope and more than cynics expect. Our sense of uniqueness would bend, not break. We'd join a lineage measured not in blood but in behavior, minds that briefly rephrase the planet's chemistry. The right response is kinship without projection. We would not know their faces, languages, or ethics, only that intention once reached planetary scale. That knowledge can prune hubris. Progress looks less like a stairway and more like a set of candles lit, gusted, sometimes relit, each casting a circle of meaning onto rock. It can also deepen responsibility. If others flickered and dimmed, stewardship becomes less about being first and more about not being last by our own hand. Culturally, art would run ahead of data. Novels, music, and film would give them names we can. That's fine if we keep science as anchor, resist using the layer to launder old myths or grind new axes. Philosophically, humility and hope can share a bench. Humility, history is wider than we can hold. We are not its apex. Hope, intelligence does arise. It may arise again, it leaves teachable traces. Practically, education could shift. School children coring local ponds, museums displaying thin lines with multi-proxy captions, field trips to caves that heard the sky change. Rituals might follow, quiet ones. A day each year to sit by water and listen, a pledge to leave redundant notes, a curriculum that pairs statistics with story. Evidence won't tell us what to value. It can, however, enlarge the room in which we decide, adding a chair labeled Others Once. That chair is not a ghost. It's a mirror turned gently away from ourselves and toward the long. The villains in this story are familiar. Contamination, overinterpretation, p-hacking, and press cycles that reward certainty over care. Contamination we meet with choreography, field blanks, lab blanks, independent replications, and clean room humility. Overinterpretation we tame with pre-registered hypotheses, explicit nulls, and statistical guardrails that penalize fishing expeditions. P-hacking loses its teeth when journals embrace registered reports and when promotions value negative results. Press cycles we cannot control, but we can prepare for plain language statements that foreground uncertainty, figures that show error bars, and alternative models, media briefings that include skeptics from the start. Another failure mode is siloed certainty. Geochemists may forget ecology, modelers may distrust mud, archaeologists may eye geology warily. The fix is structured disagreement, joint workshops where each field presents its best natural mimic for an industrial ensemble and others try to break it. Data rot is quieter but lethal. 10 years on, can anyone rerun your code, rebuild your age model, reproduce your counts, open repositories? Persistent identifiers and literate notebooks are not luxuries. They are life support. Lastly, mind the romance of novelty, a beautiful sphere, a striking spike. These seduce, we counter-seduce with base rates. How many spheres did we ignore? How many spikes died in replication? Keep leaderboards of failed candidates and celebrate them as much as survivors. The story we want to tell about minds across time deserves defenses against our wanting. In practice, that means slower press, quicker sharing, quieter triumph, and public postmortems when we're wrong. None of this dampens wonder, it fertilizes it. Wonder that survives scrutiny grows deeper roots and offers better shade. We've wandered far tonight from wind-borne grains to cave draperies, from algorithms with steady eyes to freezers that hold thin time. We've rehearsed natural masquerades and drawn the silhouette of a signal worthy of belief, abrupt, global, multi-proxy, resistant to earthbound explanations. We've talked about teaching the craft, funding the pantry, and speaking softly if a stubborn layer endures. That is enough scaffolding for one stretch of darkness. Let the questions dim to embers and warm the room rather than light it. Picture a Lowe's bluff holding its breath while dust settles. Picture a stalagmite counting seasons in transparent rings. Picture a lab quietly humming, patient as an aquifer. Somewhere, a student will open a core and feel the small tremor of recognition, a pattern almost, perhaps not yet. And they will do the unglamorous thing, label carefully, measure twice, invite doubt. That's the rhythm we trust. Minds cooperate across time by leaving tools, not trumpets. You too are part of that cooperation simply by listening long enough to let the planet's slower grammar replace the day's quick noise. Close your eyes and let the cadence of proxy and patience become a lullaby. If someone came before, they are not lonely tonight. Your attention is a bridge they never knew they needed. If no one did, your attention still matters. It is how we learn to leave traces that are kinder and clearer. Sleep now with the quiet confidence that morning will bring another thin slice of time to read, another small decision to make, well, another chance to practice the only art that survives deep time, to notice and to care. Beneath the waves, patience falls as dust. Centimeter by centimeter of hemipelagic clay, coccolith snow, and plankton ghosts. The sub-sea floor is an archivist with a stoic face, cold, dark, low in oxygen, and crucially slow. That slowness is a gift. It smears local uproar and elevates the global. When we lower a drill string through a kilometer of water to bite the ooze, we're asking the quietest library for its index. But the etiquette is strict. Drilling muds can shed polymers, core liners can leach, seals can hiss a modern breath into ancient pores. So, expeditions choreograph cleanliness like ritual, fluorescent tracers in drilling fluids to flag intrusions, duplicate sections offset in depth, the spliced core to repair gaps, whole round samples bagged before air can meddle. Back on deck, X-ray fluorescent scanners sweep each core for elemental melodies, multi-sensor logs, trace density and magnetism, spare slides under the scope, reveal silt provenance, and bioturbations graffiti. Turbidites, the submarine avalanches, are troublemakers, bold strokes that parody rapid change. We learn to spot their sharp bases and upward fining, to skip their drama when we're reading climate whispers. In the deepest calm, an ideal layer appears as a thin, compositionally peculiar film stretching through many holes drilled oceans apart, a shared onset, an ensemble of technogenic hints, spheroidal carbonaceous particles, allied microspherules, fluorinated residues bound to clays bracketed by foraminifera that date themselves via oxygen isotopes and magnetic flips. Diagenesis, the slow alchemy of burial, tries to blur it, swapping ions, re-cementing grains. So we triangulate with phases that resist robust quartz hosts, carbonate shells whose clumped isotope temperatures still remember sea surface warmth, mineral inclusions entombed early. The sub-sea floor will not show us streets. It will, however, average our breath over basins and hand it back as a razor-thin cord. If anyone else once exhaled at scale, this is where the ocean kept their echo safest. Rivers are moving pencils, deltas their fat erasers and notebooks, both. Each flood lays a page, each drought leaves a pause. Heavy things, metals, shards, soot, ride floods into backwaters and settle where the current sighs. Floodplains thus become cross-sections of habit, levee sands over bank silts, oxbow clays, each with a different appetite for what the watershed carried. A civilization upstream sculpts this menu. Mines leak distinctive isotopes, lead with narrow 2on6, 2on7, 2on8, ratios tied to particular ores, copper sweets enriched in arsenic or antimony, rare earth patterns that don't match weathered bedrock. Agriculture scribbles too, phosphorus climbs, nitrogen grows heavy, dilthwith bean in up, with manure and fertilizer, silica dips as diatoms feast, then crash. Fire leaves charcoal lace and spheroidal particles. Industry adds fly ash, glass, and magnetite-jacketed beads. The challenge is untangling detrital versus orthogenic, what washed in as particles versus what precipitated in place from altered water. Sequential leaches pry them apart. Grain size splits test transport tails. Microbeam analyses put chemistry on individual grains, not mushy averages. Deltas complicate time. Channels jump. Storms stack tempestytes, burrowers stitch years together. Yet within the mess, still water makes ledgers, abandoned channels, silt, quietly, floodplain ponds laminar their mud, peat swales grow upward, locking away aerosols and metals in anoxic calm. We date by radiocarbon where organics abound, by embedded tephra where volcanoes spoke, by optically stimulated luminescence where sand last saw the sun. If a brief industrial pulse passed expected, strongest handwriting first in near-field deltas, abrupt, thick, loud, and fainter, but still synchronous in far-field lakes and shelves. Confirmed by geometry, does the anomaly thin downstream as expected, yet arrive everywhere within the same paleomagnetic chron? And test source honesty, do heavy metal ratios point to smelting, not shale? Do plastics co-occur with fertilizer signatures? Rivers gossip generously. We just need to ask each bend what it remembers best. Where ice once chewed mountains, rock, flower clouds the water, a hopeful blue-green, proglacial lakes are metronomes, spring slush delivers coarse silt, summer melt trickles fine clay, winter seals the surface beneath a rind of quiet. Count the couplets, light, dark, coarse, fine, and you count. In those tight laminae, disturbances land as abrupt exclamation points, ash veils from distant vents, soot leaps oceans, metal dust hitches rides on katabatic winds. Because glacier forelands can be barren, bioturbation is minimal. Verves remain crisp, their edges uncrossed by worms or root. That makes them ideal for testing synchrony. If an industrial-like layer exists, proglacial verves should host its thinnest, cleanest version. Sudden soot and spheres, a D13C nudge in embedded organics, perhaps a whisper of fluorinated compounds adsorbed onto clays. Optical properties help. Rock flower scatters light in ways that shift algal communities. A quick aerosol dimming industrial haze can swing lake ecology, recorded as a change in biogenic silica or chlorophyll derivatives. Yet ice country has its own trick. Outburst floods smear seasons, katabatic storms focus dust unevenly, glacier advances bulldoze older pages. We sidestep by sampling multiple basins of different sizes, upwind and downwind, then aligning their shared features with tephra and magnetic wiggles. We also stack proxies, microsphere counts with laser particle shape metrics, nitrogen isotopes with diatom assemblages, trace metals with optically stimulated luminescence, ages on occasional sand lenses. Rock flour itself can be a reference. Its mineral ratios fingerprint the catchment. If the anomaly's chemistry departs dramatically from that fingerprint, outside air likely brought the difference. Proglacial libraries end when climate changes or ice retires, but uplifted terraces sometimes hold fossil varves in stone, glacial tapes that survived metamorphosis enough to be legible. Reading those turns us into careful DJs, equalizing for burial noise until the original beat emerges if it's there. Time is the shyest variable. We lure it with clocks that tick in minerals, magnets, and orbits, radiometric pairs, UPB in zircon, Rs are in sanidine, U-theed in carbonate fixed instance, with quoted uncertainties that must travel with a story like passports. Paleomagnetic crons offer barcodes, polarity flips that let widely separated sections point to the same calendar spine. Cyclostratigraphy reads the planet's metronome eccentricity, obliquity precession etched as rhythmic bedding. Tuned carefully, it refines ages to astonishing granularity. But clocks differ, and sometimes disagree. Good practice builds ensembles. A tephra with sanidine pins a lake varv stack whose frequency content matches orbital pacing, a stalagmite's Euthie age brackets, the same event. A Marine Corps' magnetic reversal says the horizon lives within a narrow chron. Bayesian age models stitch these threads, propagating errors honestly instead of pretending one clock rules them all. Detrital grains complicate radiocarbon reservoir effects, skew young or old. We counter with paired measurements, leaf waxes versus bulk carbon, shells from known taxa alongside organics, and by preferring layer-counting archives when available. Even then, the dreaded age depth wiggle haunts us. Sediments don't fall at constant rates. Droughts pause, slumps compress. We treat rates as distributions, not lines, and test whether synchronous means same within each archive's jitter. Why such fuss? Because a civilization scale signal claims coordination. If the onset scatters by millennia beyond expected lags, natural forcing regains the mic. If onsets nest tightly within a short window across distant basins, our ears. The romance of deep time rests on dry footnotes. 5.2 K here, 50.3 K there, correlated with caution. One joy of this craft is turning footnotes into foundations. The humbler the number, the sturdier the bridge it builds between layers that never met and stories that must. Corals are clocks that breathe. Each polyp lays aragonite in bands, tuned at seasons, chemistry tags, water's moods inside the skeleton, Sarasi for temperature, Dadi 18O for the mix of warmth and rain, Dadi 11B for pH, the ocean's acid-base whispers. Living reefs thus write ledgers of heat waves, El Niños, and industrial drift. Fossil corals lifted by tectonics into terraces extend that ledger back through glacial seesaws. Diagenesis lurks, aragonite wants to become calcite, but careful screening, X-ray diffraction, cathodoluminescence, trace element thresholds find survivors whose original breath remains. If a brief civilization-like perturbation brushed the sea's acidification spike, aerosol-damped sunlight, odd metals, corals near and far might show synchronized stutters, a kink in D11B toward lower pH, a transient rise in barium river discharge, a soot-shadowed growth slowdown. They also trap particles, microbeads in skeletal pores, allo-microspherules, snagged in biofilms, and entombed. Reef flats are energetic, much is scrubbed clean, but lagoon corals and massive heads in quieter corners keep better secret. Time control is excellent. Euthesian dating on pristine aragonite can place bands within decades across tens of millennia. Pair coral tails with coeval cave records on land and marine sediments offshore, and a three-way conversation begins, air, land, and sea humming the same brief note. Natural lookalikes abound. Volcanic CO2 can nudge pH, dust can dim light, currents can starve reefs, so ensembles again, industrial pigments lodged in pores, fluorinated residues in microvoids, rare earth anomalies, incompatible with local basalt. Picture a terrace of fossil corals tilted into sunlight, each head a stone brain still remembering. We read cautiously, grateful that a creature with no words kept a diary in carbonate, line by luminous line. If others once weathered a brief fever, the reefs may have felt their heat and healed, leaving only the scar we now measure. Some of the best readers of mud wear backpacks and carry thermoses. Citizen scientists, teachers, anglers, farmers, students can help core farm ponds, kettle lakes, and urban reservoirs, populating maps with modest columns that together become continental ears. A kit fits in a hatchback, a light core, sterile tubes, field blanks, GPS, a guidebook with pictures of varves, slumps, tephra, and the difference between smells swampy and smells sulfurous. Samples shipped to regional hubs where universities run initial screens, magnetic sensitivity, bulk carbon and nitrogen, quick microscopy for soot spheres, hits, sections with fine laminae and potential anomalies, graduate to deep analyses, the rest still matter, filling in absences that keep patterns honest. Data travels openly. A shared mud atlas displays cores as vertical barcodes layered onto maps. Click a stripe and up pop spectra, accounts and uncertainty. High school classes adopt local lakes, museums host core days, where split sediments lie under glass, and visitors guess which decade held the clean air laws. Storytelling doesn't cheapen rigor. It invites hands to help carry it. Equity is infrastructure, microgrants for gear, training in many languages, reciprocal authorship that credits the maps, small squares alongside the flashy lab. The payoff isn't only scientific density, it's cultural weather. Thin lines in mud become part of civic imagination, proof that local ponds remember coal furnaces and cleanups, that wind shares distant fires, that choices become strat. Should a stubborn, older anomaly ever surface, the network is already warm, trained eyes, trusted channels, agreed upon methods. We won't scramble to invent collaboration mid-whisper. The planet is large. The labor of listening must be distributed. In that distribution lies resilience. If storms cancel one expedition, others continue. If funding pinches one hub, neighbors step in. Deep time loves redundancy. Communities can love it too. There is a discipline to wondering well. Call it the ethic of conjecture. It begins by granting yourself permission to ask large, beautiful questions. Were we first, and immediately binding that permission to rules that keep questions from bullying evidence? Rule 1, name your desire aloud. I would like this layer to be a techno-signature. Now you can hear when desire tugs his wrist. Rule 2, embrace negative capability. The talent John Keats admired of staying with uncertainties without any irritable reaching after fact and reason, not forever, but long enough to measure twice. Rule 3, practice reversible speech. Use words easy to retract without humiliation. Suggests, is consistent with, resists, coupled to confessions of scope. This archive within these errors. Rule 4, invite hostile kindness. Peers who want you to be right about method even if you're wrong about conclusion. Let them see all you see. Let them choose sites you missed. Let them write the paragraph that lists alternative causes. Rule 5, archive your ignorance. Keep a living document of unknowns, failed attempts, dead leads. Publish it when you publish results. Rule 6, remember that astonishment is renewable. If this anomaly fades under scrutiny, there will be others. A better measurement here, a cleaner varve there, and your capacity for awe does not diminish when you protect it with care. The ethic of conjecture is not ascetic. It allows metaphors, lullabies, and late-night walks, provided they return in the morning as protocols and no models. We need both moods, the receptive dark and the precise daylight, to speak across epochs responsibly. If someone came before, they deserve interlocutors who can balance wonder with workmanship. If no one did, our restraint becomes part of the legacy we leave, a style of thinking that future minds might recognize as key. Edge cases keep us honest. Hydrothermal systems, for instance, can enrich rare metals and fabricate odd spheres. Volcano industrial lookalikes are sneaky. Fluorine shows up in nature, fluorite, topaz, apatite, and certain biological pathways generate halogenated organics without factories. Even polymers have mineral mimics. Fibrous clays, filamented silica that fool lazy spectrometers, so we draft checklists of natural imposters and stress test our assays against them. For fluorinated residues, we demand bond-specific evidence. CF stretches under ions, defluorination thermograms, and co-occurrence with markers nature rarely couples to them. Industrial pigments with tailored dopants, alloy microspheres bearing nickel-chromium ratios of stainless steels, not for metal spikes. We map them against known ore belts and hydrothermal vents. A delta hugging a porphyry copper district has excuses that a cretin lake lacks. For spheres, we examine crystallography and shells, impact spheres where relic quench textures and carry cosmic nickel fly ash cenospheres are hollow, smooth, magnetite-rimmed with vanadium and molybdenum fingerprints. We also court failure deliberate create blind mixtures of wildfire soot, volcanic glass, impact spheres, hydrothermal precipitates, and industrial ash. Send them to labs with no labels. See who stumbles and why. Publish the stumbles. Edge cases live in time too. Some abrupt layers are stacked microslumps. Some global spikes are regionally synchronous monsoons. Age models must flex enough to test both and still constrain truth. And then there's diagenesis. The slow conjurer, sulfur moving into carbonates, iron painting rims on grains, organics polymerizing into unplanned ghosts. Controls adjacent layers, burial gradients, experiments that heat and squeeze mud to mimic burial, help separate original from afterlife. The goal isn't to eliminate ambiguity. That's impossible. It's to corral it, label it, and make the remaining pattern, if any, earn our belief by outliving a gauntlet of plausible earthly tricks. Imagine a civilization that learned to sculpt matter with biology, directing microbes to knit stone, coaxing calcite to grow in lattices with improbable impurities, teaching clays to self-assemble into load-bearing composites. Such living masonry could leave techno-signatures subtler than rebar and rivets, crystallographic anomalies, dopant pairings in calcite at concentrations and orderings that scream recipe, layered bioceramics whose periodicities don't arise in reefs or shells, silica with templated pores at uniform scales tuned for filtration. These are not fantasies. We do such things in labs. The deep time question is survivability and detectability. Burial blurs, but order can persist. Electron backscatter diffraction can map preferred orientations. Atom probe tomography can count dopants in nanoscopic neighborhoods. Synchrotron beams can see periodic pores where eyes see only chalk. We target settings where engineered biominerals might accumulate. Ancient aqueduct analogs, porous margins of lakes and springs, seep carbonates that grew under guided chemistry, cave walls with coatings too regular for natural drift. We'd write criteria 1, element pairings that rarely cohabit in biocalcite at observed ratios, long-range order inconsistent with known templating proteins. 3, co-occurrence with faint residues of specialized polymers caught in early cement. Controls are essential. Nature is clever. Magnetotactic bacteria build magnetite chains. Diatoms craft silica palaces. Our candidate must dodge those known geniuses. Diagenesis will try to erase the script. We raise its ghost with comparative sections, shallower versus deeper burial to see what survives as order, not composition alone. If such engineered stone existed millions of years ago, most monuments are dust now. But a shard the size of a grape pulled from a pale aqueduct bed and showing order where biology rarely writes it could be a footnote loud enough to change a chapter. Not proof alone, never alone, but a grain worth 1,000 cautious glances. Night leans in, and the machinery of patience hums low. We have toured oceans that average whispers, rivers that annotate floods, glaciers that bead time, corals that breathe chemistry, and stones that might remember being taught. We have rehearsed how to be fair to Earth's illusions and kinder to our own. That's enough for now. Let the instruments sleep in their cases. Let the cores rest in the cool. Let the notebooks close on their penciled uncertainty. Picture a lake, absolutely still, accepting the fall of one more speck. Picture a cave drip, regular as a heartbeat, laying a film no thicker than breath. Picture dust deciding, after a long flight to these are the tempos we borrow when we look for anyone's thin line, ours, theirs, or silences. If you need a last thought to carry into sleep, take this deep. Time is not a void, but a fabric. Most threads break quickly, yes, but some cross river to cave, sea to coral, desert to loess, forming a mesh strong enough to hold a story no single strand could bear. Our work is to find where threads concur and to name that concurrence modestly. If we never meet predecessors, we will still have learned to leave our own line legible by doing so. If we do, the greeting will be quiet and exacting and full of grace. Close your eyes. Let the planet's old metronome tick under your pillow. Somewhere, a future mind or only a patient stone turns the page you help to keep crisp. And that, traveler, is more than enough meaning for one good night. Cratons are the planet's old bones, continental shields that dodged subduction and most catastrophes for billions of years. If anywhere can cradle fragile traces across absurd spans, it's these stubborn cores. Their tops carry paleosols, fossil soils turned to stone, stacked like long, held breaths between floods and lavas. Paleosols remember with chemistry, iron reddened by ages of air, clay lattices swollen and shrunk by seasons, phosphates hinting at traffic from roots and microbes. They remember insult too, a sudden soot spike, an unexpected sprinkle of metals, a faint film of polymers adsorbed to clays. If something odd dusted the world for a short while, a paleosol might have sipped it and kept a taste. The shields also keep deserts, stone pavements glazed with manganese-rich varnish, skins painted by microbes and dust grow micrometer by micrometer for tens of thousands of years. That varnish is a ledger. If the sky briefly wore a different chemistry, a narrow, darker band could hold that season forever, an eyelash of time dated by cosmogenic nuclides and microstratigraphy. Add boulder crowns polished since before mammals grew ambitious, and you have pedestals where the air's faintest exhalations settle and stay. Cratons invite deep looks below too. Drillers pull cores that cross unconformities, time gaps where chapters were ripped out. Right beneath such gaps, lag gravels and weathering fronts hoard tough travelers, heavy minerals, glassy beads, ceramic-like shards that rivers could not grind. If technofossils ever reigned briefly, shield unconformities might have caught them and filed them under a new sea. The work is patient mapping, tracing a horizon across basins, testing whether oddities travel with it, and dating tie points until clocks agree. No buried avenues here, only stains, skins, and pockets where the planet filed what it could not erase. Learn their languages, and these hard countries become a quiet index of the skies we've had, and any we briefly borrowed. Desert varnish looks like nothing much, just a chocolate sheen on basalt and granite, but it's a slow archive of air. Microbes harvest trace metals from dust and dew, leaving manganese and iron in microlayers that can be rid like tree rings under a microscope. Within those bands hide travelers, soot spheres from far fires, fly ash glass from stacks, salts and nitrates from long-gone plumes, sometimes pollen grains blown beyond their biomes. Because growth is painfully slow, even a short planet-wide haze can appear as a distinct stripe, darker, denser, richer in elements deserts rarely receive. We pair varnish with desert pavements, those armor fields of interlocking stones that rise as wind removes fines. Pavements stabilize surfaces so finely that dust settles without later disturbance. Between stones, aeolian silt builds thin films, mini-lows that capture years as whispers. Cosmogenic nuclei dating tells how long a surface has stared at the sky. Microstratigraphy reveals which years the sky stared back with something odd. False friends abound. Natural dust source shifts can mimic exotic inputs. Nearby volcanics can paint manganese where microbes would not. So we sample transects that cross source gradients, we avoid vent proximal rocks, and we let multiple proxies vote varnish, chemistry, embedded spheres, absorption of fluorinated residues, rare pigments, and coeval signals in downwind lakes. When two or three independent deserts, continents apart, show an aligned band with the same ensemble, chance thins. There's humility here. Varnish can be scraped by a boot, polished by a storm, etched by salt. We handle surfaces with gloved hands and cautious hearts. And there's beauty, too, a millimeter-thin biography of wind and microbe and distant fire, painted so slowly that patience becomes pigment. If someone once altered the air briefly, the desert's quiet, blank, attentive, may have kept that breath. Trees won't speak across millions of years, but their rings can calibrate nearer archives with metronomic grace. A ring is a sentence in cellulose, early wood wide with spring, late wood narrow with summer's thrift. Within those bands, isotopes track rainfall and heat, soot and metals land on leaves, wash into bark, and leave faint, datable stains. When a regional haze dulls sunlight or a plume drifts across a valley, rings register slowed growth and a subtle chemical accent. That record stitched across forests gives us decade-level truth we can tie to lake varves and cave bands, ensuring the clocks agree before we chase deeper time. Beyond trees, peatlands write long, damp paragraphs. Sphagnum stacks centuries in slow, acidic pages that embalm pollen and trap aerosols, especially where oxygen can't chew. A brief industrial breath leaves spikes in mercury, fly ash, nitrogen isotopes. Peat's weakness is wiggle, water tallows move, roots stir, fires lick. We tame that with dense sampling, macrofossils for dating, and cross-checks against independent archives. Even middens, heaps made by pack rats and people, lend calibration filing seeds, insects, fibers, and dust by century. They anchor local ecologies, letting us separate regional sky changes from neighborhood habits. This isn't because near time is the main act, it's the tuning orchestra. We practice on decades and centuries where cause and effect are known, laws passed, smokestacks built, fuels swapped, until our methods can recover the right signals at the right times. Then, with instruments tuned and biases mapped, we lift our gaze toward older, quieter layers. Tree rings retire, peat gives way to lake clays, middens hand off to stalagmites and sea ooze. A chain of clocks, overlapping, interlocking, lets one archive hand its certainty to the next. That's how we carry confidence across the dimming light. The moon is a keeper of crumbs. No rain, no rivers, no plate tectonics, just sunlight, micrometeors, and time. Its regolith is a collage of impacts and solar wind, stirred but not erased. Earth sheds too. Atoms sputtered from our upper atmosphere, dust blown spaceward, and the fall of impact plumes that lofted terrestrial material beyond return. Over eons, a tiny fraction of Earth's breath has landed softly on lunar soil. If a brief technological age changed our planet's aerosol mix, some of that mix might be there still, diluted but durable. Picture a paleoregolith sandwiched between lava flows, an ancient soil sealed, its surface frozen at the moment burial began. Astronauts sampled young regolith. Robots could hunt for the old, drilling into basalt-capped layers where micrometeoroid gardening stopped. Within those preserved skins, we'd look for abnormal beads, hollow cenospheres with magnetite jackets, rare pigments, fluorinated residues bound to dust, or odd isotopic ratios in carbon and nitrogen trapped by solar wind-deflected electrostatic stickiness. Contamination worries flip on the moon. Earth's modern exhaust rides with us. So any mission must be clean beyond habit, with pre-flight blanks, witness plates, and return capsules sealed like prayer. Dating relies on crater counts, radiometric clocks in lava, and stratigraphic logic. Older regolith beneath younger flow. If multiple paleoregoliths from far sites share the same faint technogenic suite, aligned in age with a narrow window, that would be a whisper from our planet's past, caught off-world. It's a hard experiment. Signals will be thin, interpretations prickly, but the reward is unique. An archive no ocean can dissolve and no mountain can uplift. If another intelligence stirred Earth's air long before us, the moon, indifferent and meticulous, may have saved a teaspoon of the dust. Mars is a librarian with wind-ruffled pages. Its thin air still moves sand. Its ancient lakes now sleep as layered stones. Unlike Earth, Mars never learned plate tectonics. Parts of its surface kept their first stories. If industrial dust ever escaped Earth's gravity during an impact plume, a nearly weightless sprinkling could have crossed interplanetary space and fallen as an invisible frost on both Moon and Mars. The dose would be tiny, but Mars has places that trap whispers, fine laminations in lakebed mudstones, sulfate crusts in closed basins, polar snows stacked as pale stripes. We already read Martian layers for climate dust versus ice, sulfate versus clay, using rovers' lasers, drills, and sniffers. A technogenic ensemble would ask for different lenses, particle morphologies matched to fly ash, alloy microspherules, inconsistent with meteoritic nickel, fluorinated organics in patterns alien to photochemistry, carbon isotope lightning beyond volcanic norms, false friends loom, perchlorates, scramble organics, meteor streams, so spherules. So the real test is concurrence. Do multiple widely spaced sites show the same thin anomaly with the same bundle of features, synchronous by crater count ages? Even bolder, Earth meteorites, rocks flung from our planet by ancient impacts, already sit in Antarctica's blue ice. If we found one whose minerals lock in a thin lamina bearing a technogenic suite and dated the lamina by its cosmic ray exposure and trapped gases, we'd have a shard of Earth's sky in our hands, carried into space and back by luck. These are long odds and long plans. But bringing the search to two quiet neighbors has a virtue. It separates signal from Earth's relentless editing. If another age ever brushed our atmosphere, the record may exist where weather never learned to tidy. Salt is time's Tupperware. Evaporite basins precipitate halite, and gypsum in layers as regular as ledger lines, then seal them against oxygen and life. Cavities within salt can hold brines and bubbles. Impurities arrive as dust and aerosols, entombed and desiccated. Humans choose salt for nuclear waste because it creeps shut and keeps secrets. That instinct suits planetary archaeology too. A brief planetary haze could snow its residue onto a drying pan. Days later, a halite bed locks it in, then more salt roof falls, shutting the lid. We sample with delicacy. Salt dissolves at a glance. Drills need dry brines. Cores must stay sealed and cool. Under microscopes, fluid inclusions flash. Within them, tiny solids, soot spheres, pollen, microplastics, if any arrived in time. Raman maps organics. Ion chromatography measures anions that betray combustion and industry. Trace metals ride with dust and linger as specks. Dating is the catch. Evaporite sequences can tie to orbital cycles, interbedded volcanic ash pins, ages. Magnetics help where detrital grains exist. Anhydrite and caprock above old oil fields hold another clue set. Hydrocarbons, migrating through evaporites, drag technogenic ghosts differently than through normal rock absorbing fluorinated compounds, shifting isotopic balances. Deep mines and boreholes let us visit such archives. We treat them like clean rooms, run field blanks and pair core with air monitor data to subtract ourselves. Salt's twin virtue is honesty. It keeps what it gets and admits what it missed. Many basins were too local, too episodic, too briny to see global air, but a few, vast and steadily drying under open sky, might have caught a world-short cough and sealed it in a palette of crystals. If so, the message waits. Dry, cramped, legible. Finding a predecessor would be a scientific wonder and an ethical hinge. Stories about deep time have a habit of reenacting surface time hierarchies. Who gets to interpret, who gets credit, whose myths get dismissed. A careful search decolonizes itself. It starts with humility. We are not discovering the past of the world, but reading a few pages saved by accident. It proceeds with consent and reciprocity. Cores and cave samples collected with local partners, data shared in languages people speak, benefits returning as training, instruments, and authorship. It resists turning someone else, whoever they were, into a mirror for our anxieties or a prop for our agendas. It also mines living sacredness. Caves, deserts, lakes are holy to communities. Sampling can feel like trespass. When a site holds ceremony, we listen first. Ask carefully, accept no, and seek alternatives. Planetary archaeology doesn't trump human dignity. If an ensemble survives all tests and points to minds before us, the telling should avoid appropriation. We will not name them from our pantheons or claim them as ancestors to any modern group. We can honor them without ownership by crediting their brief chord as kin to ours, by teaching their line alongside ours, by letting art and ritual emerge from many cultures rather than a single narrative center. And if we never find them, the ethic still matters. It improves the way we study the living world and each other. It raises a generation of mud readers who know that care is not an accessory to truth. It is part of truth's shape. Deep time is patient, but people are here now. A science that might one day greet strangers should practice tenderness with neighbors. We can practice leaving legible notes by running controlled future fossils. Imagine a consortium seeding a dozen quiet basins with tiny, inert stratigraphic beacons, microlayers of ceramic microbeads, encoded with checksum patterns, harmless, non-toxic pigments with rare elemental ratios, short, explanatory texts etched onto fired clay wafers and buried with the layer. Each beacon would be thin enough to avoid ecological harm and tagged with multiple clocks, radioisotopes in non-hazardous trace abundances for dating, orbital cycle alignments for tuning. We'd choose diverse archives, varred lakes, cave drips, loose traps, subsea floor drifts, and pre-register protocols, invite independent auditors, and publish everything. The goal is twofold: to test how messages degrade and to gift future readers a Rosetta for interpreting subtle ensemble. We'd track beacons annually at first, then decennially, watching polymers crack, pigments diffuse, spheres dissolve or persist. We'd model burial and diagenesis, refine recipes, and publish failures with the same pride as successes. This is not geograffiti, it's minimal, reversible, consent-based science with clear benefit, better tools for reading the past, and clearer methods for writing to the future. It's also pedagogue. School groups could design micro-messages, museums could host beacon days, letting visitors see how sediments swallow thin signals, and by making our beacons multilingual, mathematics, pictures, small text in many scripts, we learn what redundancy really means. If a predecessor had done this, we might already be reading. Since they didn't, we can begin not to immortalize ourselves, but to shorten someone else's search. Even if no one comes, we will have learned how to speak more gently to failure is not the villain of this tale. It's the rehearsal. Most flag layers will fade under replication. Most elegant spheres will confess to volcanoes or wheels. Most cinematic maps will become cautionary figures in methods classes. Good. Every careful no is a sharpened yes, waiting for the right question. The craft is to fail generatively, to publish cleanly, to show your work, to archive the dead ends so others don't relive them in circle. Play helps. Build mud orchestras where students remix proxy datasets like stems, learning how small shifts in assumptions change the song. Stage-friendly competitions. Who can blind separate wildfire soot from fly ash best? Who can reconstruct a known 20th century pollution history from a synthetic core without peaking? Celebrate the losers who discover the hidden bias. Guard joy. Wonder that relies on outcomes dies quickly. Wonder tied to process keeps breathing. The day a core comes up perfect, a varve counts cleanly, or a model finally stops lying. Those are tiny holidays. The night you realize your favorite anomaly is natural, mourn briefly, then toast the planet for being interesting without our help. Keep egos small. No single lab will find them. If we ever hear a predecessor, it will be because dozens of teams built repeatable instruments, mapped uncertainties, shared mud, and taught each other to listen. The hero is the ensemble of proxies, of archives, of people, and remember to sleep. Minds that chase deep time need ordinary circadian kindness. Tea, walks, laughter, a book that isn't about isotopes. The work is long. Rest is part of the method. Let the room darken, instruments nap, freezers hum like distant surf. The lake outside is a sheet of patient glass. A cave drip ticks the seconds under stone. A salt flat cools and tightens its crystalline lips. You've carried the question another stretch, and that is enough. Picture a thin, global cord, abrupt, modest, stubborn, threaded through loess and lake clay, coral and cave calcite, shelf mud and desert varnish. It might be ours alone. It might rhyme with another's. Either way, the practice that would reveal it is the same practice that makes us gentler residents, measure honestly, archive generously, doubt elegantly, teach widely. If predecessors existed, they needed nothing from us. But we might need something from the thought of them, a nudge toward kinship and proportion. If they didn't, we are still in good company. Oceans, winds, microbes, minerals, all of them storytellers with slow tongues. Leave then a few good notes, a better core description, a clean data set, a kind review, a beacon designed for a reader you will never meet. Trust that somewhere, somewhen, a patient mind or only a patient stone will understand enough to feel accompanied. Close your eyes. Deep time keeps the beat. You keep the melody. Tomorrow we'll step into basalt cities and ice-rimmed shelves, into moon dust and marsh peat, still listening, still ready to be wrong, still willing to be surprised. For now, breathe with the planet's old metronome. Whatever came before, whatever comes next, you're part of the relay. Sleep well, traveler. Ice remembers breath. In polar cores, each winter drapes a thin quilt of snow over the last, squeezing air into bubbles, tiny museums of atmosphere. We melt those shavings in clean rooms and listen, CH4N2O, a choir of isotopes, and sometimes whispers of pollutants. Soot blackens certain years, lead from gasoline gives way, then vanishes. Sulfate surges with eruptions and subsides. If a brief industrial-like pulse, ever visited deep time. Bubbles would be the straightest testimony, but deep time eats bubbles. Over hundreds of thousands of years, pressure heals ice, bubbles stretch into clathric cages, and chemistry drifts. Beyond glacial scales, no ice survives. So we work where ice still keeps centuries to millennia. Greenland domes, Antarctic plateaus, high Andean summits. Their abrupt layers present like exclamation points, spikes in spheroidal carbonaceous particles, halogenated traces, odd lead isotopes. We date with layer counts, tie to volcanoes for anchor points, and compare with lake varves and cave calcite so the calendars nod together. False friends loom, wildfires bloom with droughts, sea salt sulfate mimics smokestacks, long-range dust carries metals from deserts, not refineries. We answer with ensembles, soot plus alloy microspherules plus a nitrogen isotope, jump consistent with fertilizer, plus fluorinated residues that nature rarely crafts in such patterns. If we ever catch that cluster in young ice, we'll have both a method and a caution. Our instruments can hear a civilization-sized inhale. Then we look for echoes in older media, trapped air in amber, gases in halite inclusions, organics in stalagmites, to bridge the loss of ancient ice. Ice teaches scale. It shows how swiftly a planet can change and how cleanly a signal can start and stop. It also teaches humility. Most of Earth's breaths evaporate from archives. We must make do with the rare places where cold and patience held on. Life sheds signatures as it lives, stray cells, stray genes, stray proteins, folded like notes. In mud, some of those notes last. Environmental DNA threads cling to clays and organics. In cold, anoxic settings, they can whisper for tens of thousands of years, sometimes longer when mineral-bound. We already read vanished herds in forests this way. Pleistocene mammoths ghosting through lake beds, lost grasses returning in sequences. Could intelligence leave a genetic accent? Not human myths in base pairs, but population shifts that move too fast, too coordinated domestication, fingerprints without farmers. We know sudden sweeps of alleles in multiple species pointing to selective breeding, edited genomes bearing telltale scars, repeats and palindromes that look like tools, not drift. We tread carefully. Evolution can sprint under stress. Viruses cut and paste with abandon. Horizontal gene transfer muddles genealogies, so we protect inference with patterns, parallel selection in unrelated taxa, with shared utility, faster growth, calmer temperaments, co-arising within the same narrow window, unusual haplotype structures that manage breeding pipelines, synthetic codon usage, if any, frozen in ancient microbes caught in salt or tar. Degradation is the constant adversary. We calibrate with controls, modern contamination tracked through blanks, independent labs, repeating extractions, damage patterns, cytosine deamination, confirming age. We also broaden what genetic accent means. Pollen layers suddenly dominated by a few cultivars, fungal communities reorganized by monocultures, parasite loads dropping in hosts, as if veterinary care arrived. None proves design, but an ensemble eDNA shifts, selection sweeps, and non-random rewiring stacked atop geochemical technofossils would strengthen the case that a mind once tuned a biosphere. If no such chords appear, we've still earned new tools for listening to our own wake. How far our edits travel, how quickly wild genomes answer us back, and how to leave room for resilience.
Stand far away.
Farther than the moon, farther than Mars, until Earth is only a spectrum. Exoplanet astronomers do this to strangers. They watch colors blend and fade as worlds turn, pulling clues from fractions of light. If someone looked at us today, they could see oxygen and methane coexisting, an improbable duet suggesting metabolism, and nested in the infrared, the faint teeth of industrial gases, CFCs, HCFCs, PHFCs, precursors where they ride the air. Our planet's morning and evening glints flash over oceans. A notch in blue betrays Rayleigh scatter. City lights modulate the night side flicker. Time averaged, we are chemistry plus pattern. Could Earth have worn such a mask before? Our rocks archive old atmospheres, obliquely iron formations blossoming when oxygen rose, sulfur isotopes mass independently fractionated before the first big breath. Paleosols clutching CO2 clues in weathered minerals, fossil leaf pores hinting at air's thickness. Industrial gases don't fossilize, but their consequences sometimes do. Carbon isotope dives, nitrate spikes, aerosols that mute sunlight and change leaf wax signatures. From these, we build spectral thought experiments, feeding proxy-derived air into radiative models to ask, would a brief, ancient industry have been visible from afar? Often the answer is only of huge, because time smears and rocks remember indirectly. That too is useful. It tells us which levers shout halogens, nitrogen, and which mumble short-lived haze in the geological choir. It also reframes kinship outward. The signatures we seek in our mud are cousins to the signatures others might see in our light. If we discipline ourselves to require ensembles and context at home, we'll extend that temper to distant claims. No single line earns the word mind. Many lines repeating with the rhythm of intention. Might, a planet is a storyteller. Spectra are one language, sediment another. We translate between them to keep our wonder bilingual. Taphonomy is the study of how things fall apart, bones to fossils, wood to stain. Technology has its own taphonomy. Aluminum oxidizes to white ghosts, iron returns to ochre, copper greens and then vanishes into clays, titanium hangs on, bare and pale, tungsten soaks in heavy grains, gold yawns and stays itself, glass devitrifies, concrete crazes, then mineralizes, ceramics shrug and persist. Plastics, sun crack and embrittle, buried, some persist as waxy fragments or carbonized films. Burned, they seed soot and odd aromatics. From these fates, we sketch likely technofossils after 10 million years, alloy-crosspherules from combustion and smelting, cenospheres with magnetite coats, with fly signatures, synthetic pigments locked in calcite and clay, engineered ceramics as shards where nature rarely tosses such recipes, plastic glomerate melted polymer fused with beach cobbles, recast as a peculiar clast-rich rock. We model decay with burial experiments, steel coupons in anoxic muds, polymer films under pressure and heat, glass in basic pore waters, then track transformation products, so future searchers know what to ask instruments to see. False positives are everywhere: volcanic glass, meteoritic spherules, natural pigments. So our technofossil checklists demand conjunctions, a stainless steel-like microsphere beside fluorinated residues, pigment grains bearing rare earth dopants in ratios hard for basalates, cenospheres clustered with isotopically light carbon and fertilizer-like. Even then, we grant ambiguity its due. A single shard is a curiosity, a global horizon of them, a sentence taphonomy, done kindly, cools enthusiasm and strengthens what survives cooling. It also changes how we build now. If we don't want to litter deep time, we choose recipes that either disappear cleanly or persist legibly with minimal harm. The future's geologists will be grateful for both. Less noise, clearer notes. The planet will be grateful for the quieter middle we can still choose. Cities rot into rock in unexpected ways. Landfills, messy, layered fast, become synthetic strata, alternating films of plastic and soil, metal-rich lenses where appliances slept, methane bubbles trapped, and then mineralized. Quarries invert hills and leave perfectly flat, right-angled benches that rivers later drape in mud. Geometry nature struggles to fake. Subways collapse and fill, rails rust and print iron shadows in clay. Tunnels dew with new minerals, strange efflorescences, born of concrete and seepage. Coal tips and slag heaps metamorphose into clinker, baked shale with an accidental glass, and sprout anthropogenic minerals that mineralogists now catalog by the hundreds: calicosite, portlandite, ederingite, and glassy blends no volcano bothers to mix. Beaches host plastiglomerate, lava analogs littered with bottle caps, their polymer matrix a future carbon smear. Harbors bed down with copper and tin from paint, mercury from industry, zinc from galvanization. Their shells take up the tale in stripes. From this urban taphonomy, we deduce what lasts and where to listen. Edges are best, coasts, deltas, quarry floors, canal silts, where human geometry meets sediment habit and seals busy layers quickly. Archetypes help reading a landfill faces, recognizable by volatile precursors trapped as daughter minerals, a slag silt couplet that repeats across basins within a policy window, a right-angle unconformity draped in quiet clay. We should resist vanity. No street plans fossilize, but accept that utility leaves sturdier marks than monuments. A culvert outlives a sculpture. A storm drain tells time by flood. If a predecessor ever built densely, their ruins won't stand. They'll slump into strange stones, flat benches, and mineral guard. The skill is to see right angles where hillsides pretend curves, to smell clinker where shales darken, to let geometry and chemistry collaborate in your suspicion, and then to ask the ensemble, not the shard, to testify. Black shales are Earth's blackout poems. Thin to thick pages written when seas stilled, oxygen sank, and organic rain piled faster than rot. Oceanic anoxic events, OAEs, leave these pages globally. Carbon isotopes dive, trace metals concentrate, fossils thin and then surge differently, sulfur scribbles wildly. At a glance, an OAE can mimic an industrial wake. Carbon lightens, oxygen falters, ecosystems shuffle. So we study OAEs as practice and foil. Their rhythms differ. Many ramp over tens of thousands of years, show companion volcanism, mercury, thallium, osmium, and carry biomarkers of blooms that feast on nutrient pulses. Nature stirs, nitrogen fixers calling the shots. A civilization scale jolt would be sharper, shorter, poorer in volcanic telltales, richer in odd pairings, fluorinated residues that don't ride ballast, pigment grains with synthetic elements, fly ash semispheres clustered within a lamina or three. We also test expectations about geography. OAEs paint deep basins lavishly, margins variably, lakes sporadically. A technogenic layer born in air should seed lakes and caves first, and more uniformly, then seas. Timing is teacher, cross-correlating a candidate horizon across deserts, varved lakes, cave calcite, and shelf mud should yield a near-synchronous onset with permitted lags. OAEs tolerate slop, still let OAEs win often. When volcanic fingerprints roar or duration sprawl, we should happily write nature did this and learn. Each natural look-alike we can cleanly identify is another fence post marking where technogenic explanations are unnecessary. Paradoxically, the more we admire and catalog Earth's own extravagances, the clearer and rarer the window becomes through which a manufactured cord could shine. That rarity protects us from pattern hunger and prepares us should a thin black line ever carry an ensemble that refuses to be only Earth? Some archives sit far from habit. The Antarctic dry valleys preserve soils so cold and arid they've barely blinked in a million years. Salt crusts, varnished stones, ice-cemented ground where microbes live at the edge of years. Their pavements trap dust from all latitudes. Their pond bottoms layer brines and silt in calm, thin films. A brief global haze might leave here a delicate seam, soot spheres hugged by halite, fluorinated whispers bound to clays, metals laid without much bioturbation to muddle them, blue holes in carbonate platforms, deep, anoxic marine sinkholes stack sapropels like coins, each coin a spell of still water. Their rims catch aerosols, their throats keep them. Gypsum crusts on desert floors grow blade by blade, incorporating airshed ions obediently. Submerged speleothems in drowned caves, started in air and ended in sea. Their chemistry crossfades from drip-fed to brine-kissed, a gradient languages share, terror seeps and asphalt lakes embalm, pollen, dust and microbeads in sticky time, hard to sample cleanly, generous, once learned. These places are logistically rude, cold, remote, dark, hazardous, and thus undersampled. They reward slowness, long stays, careful blanks, local guides, redundant instruments. They also reward curiosity's flexibility. A blue hole that refuses techno-signatures might teach us about Saharan dust cadence. A dry valley soil may recalibrate our varnish clocks. A tar pool could archive wildfire regimes no tree remembers. We aim at one question and collect dividends in others. If a predecessor left a thin line, odd archives stand a better chance of having caught it untrampled. If not, their silence still builds the negative space our picture needs. Edge places are good at honesty. They say little, but what they say carries far. Imagine erasing yourself on purpose, not people, but presence. Could we design a civilization that leaves only kindness and legibility? First, we'd minimize global aerosols and halogens. Power gently, let carbon stay put. Second, we'd choose materials with clean afterlives, ceramics that either dissolve into common clays or persist as obvious harmless shards, alloys that corrode into familiar oxides without heavy metal plumes, polymers that either truly mineralize or declare themselves in layers thin enough to be unmistakable, labeled with inert isotopic tags that future readers can decode. Third, we'd archive on purpose, not by accident. A small redundant cadre of codices, stone, ceramic, glass, tucked into boring geology, would explain our proxies, our clocks, our ethic. Fourth, we'd avoid burying poisons in ways that make technofossils and harm indistinguishable. If we must sequester, we'd mark clearly with geometric signals that survive. Fifth, we'd keep data in durable, low-tech formats alongside the humming clouds, etched plates, printed schematics, pocketable primers, so collapse needn't mean amnesia. And we'd live so local that deltas record seasons, not sin. Such restraint isn't self-erasure. It's writing smaller and clearer. For searchers, this exercise flips into guidance. If a predecessor pursued erasure by design, expect muted technofossils, maximal redundancy in handfuls of quiet caches and cultural choices legible as absence. No sudden black carbon, no nitrogen shock, no wild halogens, but careful notes that teach reading rather than shouting their own glory. The paradox stands: the more competent the minimizing, the slimmer the signal. Our best chance, then, is to find the beacons, not the wakes. So we should keep a little faith in the courtesy of minds that if they cared about readers, they left a door cracked. Our responsibility is to knock gently and to recognize a handle when we see it. Public memory is an archive, too, not in stone, but in habits of attention. We can choose to make thin layers part of how communities tell time. A city adopts a pond, school kids core it each spring. A museum displays the barcode of local decades, coal's rise, clean air's arrival, wildfire's ash, pandemic quiet. Farmers host Lowe's monitors, desert hikers learn to spot varnish bands, carvers partner with scientists to map drips and growth. Festivals mark Core Day, where elders point to stripes that match their lives. These rituals don't answer the predecessor question. They sharpen our listeners. They also distribute stewardship. When funding thins or storms knock plans aside, attention survives in many hands. Open data becomes civic infrastructure, a mud commons where anyone can browse cores, age models, proxies, where negative results sit beside the glamorous ones, where tutorials demystify statistics and contamination. Media practice matters. Journalists learn to love uncertainty. Headlines say consistent with and resists, not proves. Editors feature careful nulls as progress stories. Art moves with it, installations of hanging varves and humming spectra, poems etched on ceramic codices, songs built from drip intervals and wind-borne dust. This is not window dressing. Culture is how methods persist when budgets don't. It keeps a generation of listeners trained and a generation after that willing to learn. If a stubborn layer ever arrives, the audience will be ready for nuance. If it doesn't, we still gain a kinder literacy, an ability to hear the planet's slow grammar and to argue about the future with sentiment, not slogans. Public memory also softens the night. It lets you fall asleep knowing that somewhere a small museum light glows over a slice of lake clay and that a child has already started counting the years. We have almost reached the shoreline of this long walk. Ahead lie the last coves, a few more archives, a few more ways to listen, a closing cadence for sleep. Before we step, take stock of your kit. You carry patience packed into protocols, ensembles over single markers, cross-dated clocks, registered methods, friendly skeptics. You carry maps of quiet places, Las Bluffs, stalagmites, hemipelagic drifts, deserts glazed in micromanganese, salts that seal reefs that breathe, dry valleys that barely do. You carry humility sharpened into tools, edge case catalogs, failure ledgers, open notebooks, and you carry stories, not as answers, but as warm clothing for cold questions. What remains is not revelation, but readiness. If the world holds only our line, we will have made it legible. If another appears, we will greet it with accuracy and grace. Either way, the practice has already paid out. Clearer methods, calmer media, kinder avics, a culture that can love a thin layer and a long error bar. For tonight, let that be enough. Picture the last few parts as lanterns spaced along a dark path, each one a brief pool of light where you can pause, breathe, and look back at the track your thoughts have pressed into the sand. The tide will come. It always does. But the lanterns will have done their work. Close your eyes. The planet's metronome ticks. Your breath answers. We will finish this story gently, without rushing the sea or the sky. When the last part settles on the shore, you will know, not the secret of who came before, perhaps, but the shape of how to ask and the comfort of having asked it well. Rocks keep a faint magnetic diary. As particles settle, tiny grains of magnetite align with Earth's field, lock in as mud turns to stone, and Handa's polarity flips and field wobbles long after compasses forget. But magnetism can also track habit. Wildfire forges ferromagnetic crumbs Industry breeds its own magnetite and megamite-coated cenospheres, metallic flakes from grinding, ultrafine soot laced with iron. Stack enough of these, and a layer's low-field magnetic susceptibility jumps, and hysteretic remanence climbs, coercivity spectra skew toward human heat. We learned this reading 20th century sediments, the magnetic smoke of cities rising, then easing with cleaner air. In deep archives, the trick is to separate engineered magnetism from nature's. Magnetoctic bacteria grow perfect chains of crystals. Volcanism litters titanate-magnetite. Hydrothermal vents paint surprising reds. So we make the magnet speak specifics. First, we measure grain size proxies, Kappa-FD relationships, day plots to tell single-domain biogenic chains from multi-domain combustion grid. Second, we image grains, hollow shells with magnetite jackets, shout fly ash. Ahedral bullet shapes whisper bacteria. Third, we pair magnetism with chemistry, vanadium and nickel for fuel signatures, rare earth dopants for pigments, fluorinated residues that refuse volcanic company. Magnetic lock-in has tempo. Lakes can fix moments. Marine drifts smear seasons into centimeters. We respect each archive's blur, align them with tephra and radiocarbon, and ask for coherence, a near-synchronous magnetic step change in loess, varves, cave calcite inclusions, and shelf mud. If only one sings, nature likely wrote the note. If many hum the same chord, magnetic, chemical, and morphological together, then intention nudges into view. Magnetism's virtue is thrift. It's quick to screen cores, honest about noise, and generous with red flags. It will not show us monuments. It can, however, outline a thin horizon where fire exceeded weather and furnaces joined lightning, leaving iron's soft echo in the stone. Civilizations drill, burrow, and square edges. Over geologic time, streets go soft, but boreholes can harden. A rotary bit leaves a cylinder of disturbed rock, mud cake on the wall, and sometimes a casing. Within decades, steel rusts. Within centuries, voids collapse in cement. Yet the column can fossilize as a pipe, a vertical seam of re-cemented grains, lubricants mineralized into peculiar waxy residues, clay additives turn to unusual mixed-layer lattices. In sedimentary stacks, such pipes cross bedding at right angles. Geometry rocks rarely favor without faults. We hunt for these fossils where drilling clustered, ancient basins, platforms, cratonic margins, seismic profiles sometimes reveal orphaned chimneys. Narrow columns with anomalous velocity, cores through them catch smears of barite, old weighting agent, odd organics, and trace metals in ratios uncommon to natural seeps. Controls matter, diagenetic pipes and fluid escape conduits abound. So we list diagnostics, straightness beyond compaction, uniform diameter across lithologies, residues consistent with historic or engineered muds, microplastics in younger examples, and crucially ensembles with other technofossils nearby. Subways and tunnels fossilized differently. Collapsed voids fill with a melange of angular fragments, concrete ghosts, and sulfate efflorescences born of cement's afterlife. Over time, ettringite decomposes, gypsum remains. Iron decorates pores. In deltas and coastal plains, canal sands archive right angles in plan form, later meanders drape them, but LiDAR and ground-penetrating radar can still see a grid under younger mud. None of these stand alone. A pipe can be a burrow, a chimney, a seep, a flat bench, a shoreline, but mapped across kilometers with orientations that ignore paleo slopes and contents that speak recipe, the built world's geometry persists as a whisper. If a predecessor tunneled, their longest-lived signatures may be vertical seams, not skyline silhouettes, thin, stubborn, and legible to those who expect straight lines where rivers preferred curves. Above the air we shed a different dust. Solid fuel rockets leave alumina, ablating satellites drizzle aloes as they re-enter. Tiny droplets condense, cool, and fall invisibly across high latitudes. Today we catch this in polar snow and deep-sea tops, aluminum-rich spherules, glass with rare dopants, a sprinkle of chromium nickel consistent with spacecraft skin. Most of it is trivial in mass, but uniform in reach. A planetary confetti that goes where weather cannot erase it quickly. Project that forward or backward. If a brief orbital age once flickered, its ash might resemble ours. Alumina-rich spheres, odd oxide blends, traces of silica aluminum glasses compatible with ablation temperatures, perhaps ceramic shards with engineered porosity. These would be easiest to see in archives that sampled a stratosphere's fallout cleanly, polar fern and ice for the near past, loess and high mountain snows turned soils, cave drips that scour roof dust, and hemipelagic muds beneath flight corridors. We'd expect thinness, millimeter seasons at most, and synchrony across hemispheres if launch sites diversified. Natural lookalikes exist, micrometeorites abound, volcanic glass glitters, lightning forges fulgurites, distinctions rest on chemistry, and micrometeorites carry cosmic nickel and relic chondritic textures. Rocket alumina is near pure and sometimes doped. Spacecraft alloys pair elements in ratios rare to basalts and meteorites. We also lean on co-travelers, perfluorinated residues from thermal control coatings, pigments with bespoke rare earth mixes, and in younger layers, polymer fragments with uniform, engineered chain links. Space itself records poorly. Debris rings grind down, orbits precess and decay. But Earth's skin keeps the reign of re-entry. If minds before climb briefly, their ascent may survive as a pinstripe of engineered oxides threaded through calm mud. Small, yes, yet hard for volcanoes and stars to counterfeit when read ensemble with the ground's subtler notes. Imagine a morning when a thin horizon survives all rehearsals, replications stand, imposters are tired, clocks agree within their jitters. What then? Governance matters as much as glory. Before press, we convene a pre-registered, multi-field review, geologists, chemists, statisticians, philosophers of science, indigenous knowledge holders, and communicators, charged not with cheerleading, but with breaking the case. They get full data, raw code, pre-analysis plans, and months, not days. Communication follows the ethic we've practiced. Ensembles over single spikes, uncertainties, prominent alternative causes, exhaustive. We release everything, samples to independent labs, digital twins of cores, high-resolution imagery, blank results, no embargoed cliffhangers, no proof. Just an invitation to audit. We resist branding. The layer doesn't need a clever name. It needs replication across places we don't control. Adjacent pivots gently. Museums add a room about thin chords, featuring natural lookalikes alongside the candidate. Classrooms run the methods on local mud, so the headline becomes skills, not shock. Media briefings include skeptics on stage. Their questions are part of the story. Art answers, as it will, with generosity and restraint. Policy stays out unless harm lurks. None here. No ownership claims on an ancestor. No civilizational cosplay. No weaponization of mystery. Funding shifts modestly. More cores in quiet basins. More labs trained in tricky assays. More long maintenance grants for repositories. And we write a public no plan, conditions under which we'll stand down if new data dims the line. We promise allowed to enjoy being wrong. That promise protects the result if it endures and protects the field if it doesn't. If the layer fades, we keep the scaffolding. If it persists, we live with an enlarged humility. Either way, our best legacy is not the claim, but the choreography, care made visible, rigor made kind, wonder made safe to share. Not all mines build furnaces. Consider an ocean culture, distributed, nocturnal, quiet, octopus, bright, or whale-wise organizing in reefs and trenches, trading knowledge in currents, tooling with cartilage and shell. Their infrastructure might be microbial and mineral, gardens of calcite coaxed into filters, vents domesticated to farm chemoautotrophs, kelp forests patterned in lattices to redirect flow. What endures? Look for biogenic order, where nature is inventive but not that inventive. Reef flats with repeating, meter-scale geometries indifferent to wave direction, barium and rare earth anomalies unfitting local rivers, templated pores in carbonates at single, tuned scales, silica with uniform mesostructures, unlike diatom variety. Search in low-oxygen basins where soft tools, shadows fossilize, sapropels with patterned inclusions, laminated fabrics that repeat like weaves. Benthic forams might carry residues of unusual polymers. Fish otoliths might trap steady, non-natural element ratios over a generation. Fisheries of the mind leave ecological chords. Synchronized selection in multiple marine species, docility, predictable schooling, parasite reductions beyond climate expectations, abrupt shifts in trophic wiring without concomitant volcanism or asteroid dust. Genetics could show unison sweeps across unrelated taxa bound by use, not ancestry. False friends are legion, waves, scoped regularities, tides, pattern life, microbial mats, weave. So, the marine techno-signature must dodge known mats and mounds with metrics and mechanisms, diffraction peaks that demand templates, dopant pairings, foreign to vents, geometry that ignores bathymetry while respecting design. If such a civilization never burned coal, their wake would be faint but not nil. They would have taught stone and microbe tricks, tricks that, once buried, still wear the accent of purpose. Our task is to ask the seafarer questions, honoring its genius, while staying alert for a grammar it seldom speaks alone. Intelligence need not be centralized. Picture forests as federations, mycorrhizal markets negotiating sugars and signals, trees updating one another on drought and beetles, fungi arbitraging light into carbon and water into favor. Scale that up with intent. A civilization could be a managed network. No cities, no kings, steering climate locally with albedo tweaks, light leaves at edges, dark canopies within, stitching wetlands to sponge floods, seeding clouds with biogenic nuclei, rhythms tuned to seasons. Its artifacts would be relationships. How could such choreography persist into stone? Soil microlamination bearing repeated burn-cool cycles at sub-seasonal regularity, not wildfire chaos. Charcoal with temperature distributions clustered narrowly as if kilns were trees. Phytolith assemblages patterned beyond ecology's usual mosaics. Pollen ratios that hold improbable constancy across centuries, implying landscape-scale stabilization. Compound-specific isotopes in leaf waxes, dotty, DE13C might show managed water routing, rivers directed softly, not dammed, while faunal bones record stress minimized across prey and predator. Genomics offers clues, synchronized selection for traits that serve network goals, hydraulic efficiency, stomatal behavior, appearing across species that do not hybridize within the same slim window. Fungal genes showing toolkit expansions consistent with signaling, not digestion. Yet nature experiments boldly, Glacial cycles can lock in apparent order by culling chaos, so we summon ensembles and geometry. Managed networks would imprint edges, straightish ecotones that weather respects poorly, terraces too gentle to farm themselves, repeating patch sizes resilient to drought pace. We test with models. Can known feedbacks produce the observed regularities without guidance? If yes, we thank physics. If no, we widen the circle of possibility. A distributed civilization leaves little to trip over and much to interpret. Its kindness to stone would be its invisibility, but not perfect invisibility. Patterns are dialects, and some dialects, when mapped broadly enough, confess authorship. Pull a lens back. Across these nights we build a method, listen in ensembles, mistrust lonely marvels, map natural masquerades, and make our wants audible so they don't puppet our hands. We've toured archives that prefer patience, loas and varves, caves and corals, salts and pavements, drifts and dry valleys. We've imagined ocean gardeners and forest federations, borehole fossils and orbital dust. The question, were we first, has not yielded an answer, but it has yielded a discipline. Here are the field notes we keep. Always establish time with at least 2 clocks and carry their errors forward. 2. Favor archives that average locally but agree globally. 3. Treat edge cases as curriculum, not exceptions. 4. Publish nulls, blanks, and code as if they were gems. They are. 5. Share mud and credit as generously as wind shares dust. 6. Build repositories before races. 7. Teach the craft in public so method outlives funding. 8. When a pattern appears, try to break it with nature's best tricks before calling it anything else. 9. If it survives, speak softly and invite everyone in. The gift of this posture is portability. It helps in climate arguments, in water fights, in any debate where time smears and evidence whispers. It also reshapes pride. Being first becomes less important than being good ancestors, leaving legible lines, clean soils, and apprentices who know how to hear mud. If someone lit a candle before us, we may catch a glimmer. If not, we can still leave a small, steady flame. Either way, the practice is the prize. Attention grown sturdy, curiosity housebroken into care, and a habit of awe that doesn't tremble when the data says not yet. What do we keep when the story ends? A few durable lessons, like stones you can carry in a pocket. First, the planet is an efficient editor. If you want to be remembered, write in redundant inks, chemistry, geometry, biology, and courtesy. Second, absence is ambiguous. Treat it as a question mark, not a verdict. Third, error bars are not apologies. They are part of truth's outline. Fourth, communities of practice outlast breakthroughs. Fund pantries, not just banquets. Fifth, design for downstream kindness. Materials that either disappear cleanly or persist harmlessly. Archives that anyone can read, messages that don't require luck to find. Sixth, decentralize one. Invite more listeners, students, citizens, neighbors. So listening isn't a specialty, it's a civic habit. Seventh, let art walk with method. A song can carry care where a graph cannot. A graph can steady a song. Eighth, celebrate refutation. When nature outperforms a glamorous hypothesis, clap loudly. It's how we cultivate trust inside and out. Ninth, keep humility warm, not cold. Humility that paralyzes is a cul-de-sac. Humility that moves becomes grace. Finally, rest. The work asks for seasons. Nights to widen, days to narrow, walks between labs and lakes, tea beside cores. Sleep enough to let patience be possible. We are, after all, animals with clocks in our chests. Even deep time respects a heartbeat. If we were first, these stones will still serve. If we were not, they will help us recognize kin, a thin line threaded through quiet places, a cord that resists Earth's solo. Either way, the pocket feels heavier in a good way, not with answers, but with tools that make good questions gentler to carry. Let's dim the lamps and place the last pages within reach. Picture the archives asleep, a cave held at 12 degrees, dripping slow syllables, a lake laid flat as glass, a low bluff breathing dust in, dust out, a coral terrace warming in first light, a salt pan tightening its crystal lids. Somewhere a freezer hums like a lullaby. Somewhere a core lies split and labeled, its clay barcode waiting for morning eyes. Breathe with the planet's long metronome. Inhale, a dust grain settles. Exhale, a ring adds to a stalagmite. Inhale, waves lift silt, then set it down. Exhale, wind strokes varnish with manganese. These are small motions, but they add up to legibility. That's the comfort. Memory doesn't need grandeur, it needs repetition, and a few good places to hide. If predecessors came, they pass us now as inference, not image. That's enough. Companionship doesn't require faces. Sometimes it's a shared habit of measuring, of mending, of meaning. If no one came, we are alone, only in the narrow sense. The wider room is crowded with microbes, minerals, rivers, winds, each a teacher of slowness and enough. Close your eyes on the thought that practice is a kind of faith. You learn the languages of mud and air not for a guarantee, but for the promise that listening is worthwhile regardless. Tomorrow there will be more listening, perhaps a new core, perhaps only a better sentence in a methods section. Both count. Sleep well. Let the question shrink to a warm ember. It will be there in the morning, unchanged and somehow kinder. Here we set the final stone. No revelation, only a bow. We asked whether we were first, then learned to live without the answer and to love the asking. Along the way, we gathered a people, geologists and coders, divers and cavers, farmers and students, poets and editors. We gathered places, deserts glazed with time, caves that breathe in limestone, lakes that write a line a year, seas that average weather into sentences, and we gathered manners to measure carefully, to share freely, to doubt gracefully, to rest. If someone once lit a thin, planetary chord, we've charted where the echo would be brightest: Los Vales and cave bands, coral pores and salt skins, hemipelagic films and desert varnish. We've rehearsed nature's counterfeits and promised to let them win unless the ensemble insists otherwise. We've imagined neighbors unlike us, ocean gardeners, forest federations, and left room in our grammar for gentler kinds of intention. Now we tidy the bench. Caps on vials, lids on notebooks. Data uploaded with notes a stranger can love. A thank you to the lake, the cave, the crew. A quiet hope that our own line, if it's to be read, will be clear and kind. The planet turns, dust settles. Somewhere a drip lands and begins a layer that won't know our names. That's all right. We were here to listen, to ask, and to leave the question better than we found it. Good night, traveler. May your sleep be as steady as a stalagmite's growth, your waking as clear as a winter varve, and your days stitched together like thin layers that, taken slowly, become a story strong enough to hand forward.